Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. So in this course, we are going to be looking at learning the Unity game engine. Okay, Unity is a game engine, which basically means it is a tool that we can use in order to create pretty much whatever sort of game we want to make. Okay, so let's look a bit at Unity. Now, Unity is a cross-platform game engine which is used by millions of people around the world. Okay, it is the most popular game engine, and more than half of the mobile games you see on the App Store were created using Unity. So, Unity also is very versatile, and this basically means that we can create any sort of game ranging from 3D to 2D, mobile, console, multiplayer, virtual reality, and even augmented reality games, okay? And along with all these different things that we can create, Unity also allows us to build to pretty much any platform you can think of, okay? Android, iOS, even if you want to build to Microsoft VR headsets, okay? Unity has the tools available to do that. Now, what are the goals for this course? Well, first of all, we want to learn the Unity editor, okay? This is a piece of software that we need to get accustomed to, and we also then need to look at all the different features that Unity has and that we can use in order to develop our games, okay? So we'll be looking at each of these individually so that by the time we reach the end of the course, you yourself are rather familiar with the engine and you're comfortable with using it. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with our first lesson. Hey everyone, and welcome. In this lesson, we are going to be looking at installing the Unity Hub. Now, this is basically a program which allows us to manage all of our different Unity projects as well as different versions of the Unity editor. So let's hop over to unity.com and look at how we can begin. So here I am at the unity.com website. And pretty much what we want to do is go down to where we have this blue download Unity button. Okay, we're going to click on that, and that is going to navigate us over to the downloads page. Now, you should see then a download button here. For me, it says download for Windows, but if you're on Mac, it should say, download for Mac OS. So I'm just going to click on that, and it is going to begin downloading the installer. Okay, and once that's done, we can open up the installer and begin setting it up. So, first of all, we just want to click on I agree. We then want to choose a location to install the Unity Hub to. Normally the default location is probably the best. Then click install, and that's going to begin the process of installing it. And once that is done, you should see we have the completed setup page right here. Make sure to enable Run Unity Hub, click finish, and we should then have the Unity Hub open up for us. Okay, and when the Unity Hub opens up, you may have this little pop-up appear. We're not going to install it this way because for some people it may not appear, so we're just going to click on Skip Installation at the bottom right here. And you'll see initially that we are at the installs page, okay? So if you're not here, you can go over to the left-hand side on the navigation panel and click on Installs right here. And this is basically where we are going to have all of the different versions of Unity installed for us, okay? Right now, of course, we have nothing, so let's install Unity. So I'm going to go over to the top right corner of the screen and click on the Install Editor button right here. And that is going to open up this window, okay? Now, what we want to do is we just want to find the most recent long-term support version of Unity, okay? So right now I've got 2021.3, which was released now in 2022, and you should see it says recommended version, okay? So find the recommended version, click on the install button here, and that is going to bring us over to the modules page. Now, Unity doesn't have all of the build platforms installed by default because it takes up quite a large amount of space. So if you do want to build to Android or iOS, you can enable them right here. Or later on, if you want to change your mind and you might think later on, okay, I want to build to Linux now, for example, you can come back to the Unity Hub and install the modules afterwards. Okay, we're not going to install any modules now, but we do need to make sure that we have Microsoft Visual Studio Community here enabled, because that is going to be the program we use in order to write our code. Okay, so we need that enabled, of course, and that is around 1.2 gigabytes in file size, and in total it should be around 6 gigabytes. Okay, so make sure you have enough space available for that, and we're going to click continue. We then need to accept the Visual Studio Community License terms and click install. Okay, and that is going to begin the process up here. Now, since it is around 6 gigabytes in size, it may take some time depending on your internet and computer speed. So wait for that to finish and then continue on with the next lesson where we look at actually creating ourselves our first project. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can create a new project inside of Unity. Okay, so let's go ahead and open up the Unity Hub. Now, inside of the Unity Hub here, in the previous lesson, we went over installing our version of Unity. So we have the editor now installed. Do make sure that is complete before you continue on with this lesson. Now, depending on the size of the editor, it may be a couple gigabytes. That can take quite some time, so do make sure that the editor or the install has completed. Now, what we can do is we can go over to the Projects tab right here at the top left corner. And inside of the Projects tab is where we have all of our different Unity projects listed out. Now, you can see I already have some right here, but for you, it will most likely be empty. So how do we go about actually creating a new project? Well, we want to go to the blue button at the top right corner, which says New Project. We'll click on that, and it's going to open up this window right here. Now, inside of this window, this is where we want to basically choose a template. Now, a template is sort of the way that Unity sets up the editor for us to use. The two main common ones are going to be 3D, which is already selected for me, and 2D, okay, because Unity can create both 3D and 2D games. So basically, if you want to create a 3D game, you click on the 3D template. If you want to create a 2D game, you can click on the 2D one here. Now, if, for example, you click on the 3D template, you open up the editor, you start making your project, and then you're like, I actually want to make this a 2D game. Well, Unity doesn't sort of like lock you off from doing that. Rather, all these templates are just Unity changing some settings that you can, of course, go ahead and change yourselves in the editor. So you can easily make a 2D game with the 3D template if you wish, but it's just a bit easier since Unity sets some stuff up for us already. Okay, so don't think of templates as different versions of Unity. More so, they are all the exact same version of Unity with just a little bit of different things done to them before we get to actually create our game. So I'm going to click on the 3D template right here. And then on the right-hand side, we can give our project a name. I'm going to call this one Intro to Unity. And then we can choose a location for this project, okay? And you can have a dedicated folder on one of your drives if you wish, or wherever you want. So once you have a name for your project and a location assigned, we can click Create Project, and that should close the Unity Hub and open up the editor. And after around a minute or two, the Unity editor should open up, and now we can begin creating our games. Hey everyone, in this lesson we are going to be looking at the Unity editor, and we are going to basically see how it works and how we can navigate around it. So let's look at the Unity editor. Okay, now upon creating a brand new Unity project, you're probably looking at this and being a bit overwhelmed, okay? There's lots of buttons, lots of different windows, lots of different inputs and all that, and probably a lot of names and labels that you don't really understand, and that's entirely fine, okay? In this lesson, we're going to go over each of these windows and basically see what they are and how do they serve us in creating games. So, when you open up Unity, you should have this default layout right here with these different windows visible. Now, what is a window? Well, in Unity's terminology, a window is basically like a little panel. As you can see here, there are these individual segmented rectangles, and each of them serve a different purpose. Okay, you can see over here we have a little tab which says its name. We have the hierarchy, we have scene, we have project, and we have inspector. And over here on scene, for example, you'll see that there is also a little other tab. It's a bit like a web browser where we can switch between two different tabs, scene and game. And game is basically where we'll be playing our game to test it out. Same thing for down here in the project window. We have project and then we have console, okay? So what are these windows? The hierarchy basically lists out all of the different objects that we have in our current scene, okay? You can see right now we have a scene name, which is sample scene, and we have two objects, okay? We've created a new Unity project and we are basically given a bare bones scene to contain our game. And we have a main camera, which is basically what our game is going to be rendering to, and a directional light. Now these two objects are here by default, and look what happens if I click on the main camera, for example. I'll click on it and you'll see a few things happen. First of all, over here in the scene window, okay, which is known as the scene view, we have the camera selected, okay? You can see over there, we have that camera selected and we have this weird looking thing on top of it, which we'll go over a bit later. And as well as it being selected in the scene view, we also have the inspector window over here change quite a bit, okay? And now the inspector basically is listing out all of the different properties and components that this camera has, okay? So the hierarchy lists all of the different objects in our scene, and the inspector basically inspects whatever object we have currently selected, okay? So if I click on directional light, you'll see all of a sudden the inspector changes, and now we are looking at all of the properties on the directional light. And you can also see over here in the scene view that selection changes as well. So we've got the hierarchy where we can select our objects. We have the scene view, which is basically like us looking into our game world, where we can see all of our objects. And we have the inspector, which basically has a closer, more finer look at whatever object we have selected, so we can look at its different properties, and we can of course go ahead and modify them, okay? For example, if we want to make the camera's field of view larger or smaller, we can modify that property right here. Something else is that we can also select objects directly in the scene view. Now, it may be a bit hard, but you can see there is this little sun icon right here, and this sun icon is there to represent this directional light. Now, we can select that directional light by clicking on it inside of the hierarchy here, or we can go ahead and click on that little icon in the scene view, and that basically does the exact same thing, okay? We have the properties in the inspector, and we can modify them there. But what is the project window down here, okay? The project window or the project browser is basically the file explorer for our project. Whenever we created a new project for our game right here, what we have basically done is created a new folder somewhere on our computer. And that folder basically is going to contain all of the files and all of the assets that we'll be needing for our game, okay? So you can think of it like all of the textures, materials, 3D models, sprites, sound effects. Now, you can see by default, we have one folder here, okay? Our scenes folder. Now, what we can do is we can just double click on that folder to open it up. And when it opens up, you'll see that we have one file right here, okay? We can click on it, and you can see that is called sample scene.unity. Now, the way that Unity actually organizes itself is in what's known as a scene. And a scene is, you can think of it like a level, okay, where you have sort of your self-contained environment, and you can have multiple scenes which sort of act, yeah, like I said, as levels. And we'll go over that a bit later on. You can also navigate your project files over here on the left-hand side, where we can click back on our assets folder, which is the root folder. And we can also go ahead and create new folders. For example, we can right-click, go create folder. That will basically create us a new folder here. And if we wanted to import some sound effects, for example, we could open up a window, like a file explorer, and just drag them in, okay? Just drag them in here, and they will import. Now, also next to the project tab here is console. And the console window is basically there for us to see any sort of messages that the editor wants to tell us. So for example, if we're playing our game and there's some sort of error in our code or error in the way we set up an object, it will log a message to the console explaining what the issue is. And finally, we have the game window, okay? And the game window is basically where our game is going to be rendered, okay? What you see right now is basically what our main camera over here is seeing, okay? If we click over into the scene view, you can see our main camera over here. It's kind of hard to really understand what's going on because we don't really have any physical objects in our scene. But yeah, the game view is basically showing us what our main camera is seeing. And what we can then do is go up to the top here and click on the play button, okay? You'll see there are 3 buttons. We have the play button, the pause button, and the step button, okay? So if I click on the play button, that's going to basically gray out the editor a bit, and now our game is playing, okay? So if we would have objects, if we would have some sort of controller, we'd be able to, play our game and test it out. You can click on the pause button here to pause it in case you want to pause an action in time to go change something or go check something. And then we have the play button to basically stop playing the game. And then when you're playing the game, you can click on the step button right here to basically go forward 1 frame at a time. But I don't really find myself using that function too often, okay? It's mainly just the play button and the pause button. So again, when you're in the play mode right here, you'll see that the screen has sort of gone a bit darker, and the play button is now blue. And if you click on the blue play button, it will stop playing the game. Now, something else I want to show you is the fact that the Unity editor is very customizable, okay? These aren't all the windows that you will be using. In fact, you can go up to here at the top, click on window, and you'll see here how many different types of windows there are. There's windows for animation, audio, AI, setting up UI and everything, okay? There's plenty of different windows, but how do we actually move them around? Okay, well, pretty much what we can do is just like with a window on your computer, you can click and drag on the sides to basically resize it, okay? So as you can see here, I can click on the edges of these windows to resize them. I can even, for example, click and hold on one of the tabs of the window here and drag it out, and it drags out into its own individual window. I can then go ahead and dock it. As you can see, it sort of automatically snaps wherever I'm dragging, so I can chuck the console up here. But for me, typically, I like to put the console next to the project window here, okay? So we have both the project browser and the console visible at all times. And I do like to make my inspector a bit wider just because there is a lot of information that we need to display. Okay, so that is a look at the Unity editor right here. Now, one more thing, and that is if your editor, if you're messing around with some windows and you accidentally close them, and you want to go back to the default. If you want to go back to the default layout, you want to go to the top right corner here where we have the layout drop down and just click on default, and that is going to swap you back to the default layout. But I'm going to get the layout that I like with the console over here on the side and the inspector window a bit wider, like so, and there we go. So feel free to explore the Unity editor, move around the windows, and get ready for the next lesson where we start looking at how we can actually navigate around our scene. So I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at scene navigation inside of Unity. Now, scene navigation is basically the way that we can control the scene camera in order to build our levels. So let's hop over to the Unity editor right now, and what we're going to do is we are going to be looking at this center scene window right here, okay, the scene viewport. Now, the scene viewport is basically our eyes into our game world, okay? We also have the game view right here. Now, the game view is a bit different. The game view is what our camera object here is seeing, okay? And this, in turn, is going to be what our game is going to look like when we press play. Whereas the scene view is basically a way for us to fly around, select objects, move them around, and just overall build and construct and modify our levels, okay, here in the editor. So how do we actually do all of that? Well, first things first, what we can do is if we have our mouse over the scene view, what we can do is we can hold down right mouse button, and you should see that your mouse cursor turns to this little eyeball icon. And what we can then do is we can just look around as if we are playing a game, okay? So we can hold right mouse, look left, up, down, and right. Okay, so it's pretty cool that way. So we can look around. Now, what about moving? Well, if we hold down right mouse and we are looking around like so, while we are doing that, we can use the W, A, S, and D keys to fly around. Okay, so W to go forward, S to go back, A to go left, and D to go right. We can also move vertically, so if we press E, we can go up, and Q to go down. So using those 6 buttons, we can basically fly around our scene here, and as you can see, we don't really have much to look at, so what I'm going to do is I'm just going to quickly add in a new object, and that is going to be a cube. So the way we can do that is by going over to our hierarchy right here, and you'll see at the top left of the hierarchy window, there is a little plus. So I'm going to click on that, and this is basically where we can create all different types of objects for Unity. So I'm going to go over 3D object and I'm going to click on cube, and that is going to create a brand new cube in our scene right here. You'll see it pops up in the hierarchy. We can select it. You can also see that with 3D models inside of Unity, in the scene view, they have a little orange outline whenever we have them selected, and we have all the details here inside of the inspector. So we have our cube there just as a bit of a reference for us to see when we're flying around. Now, what happens if you are, let's just say, on the other side of your map working on something, and you're like, all right, I want to go back to the cube. Well, you could, of course, hold down right mouse and fly over there, but a much quicker way is if you know what the object is that you want to go to, you can select it here in the hierarchy, okay? You'll see it's highlighted blue, and then you can press F on your keyboard, and that is going to focus in on the object, okay? So we could be over here, press F, once we have an object selected, and we'll focus in on it. I can select our main camera now, press F, and we'll focus in on the main camera. Same thing for the directional light. Now, while we've been doing this, you've probably noticed that we have this little gizmo at the top right corner of our scene view, okay? And it sort of rotates whenever we look around. Now, this is what we call the scene view orientation gizmo, okay? And this basically allows us to quickly orientate the camera along certain planes of view. So let's just say we wanted to have a bird's eye view of our level, okay? We could, of course, fly up, look down, but, it's not exactly 90 degrees down to the ground, so what we can instead do is click on the green sort of arrow here, the green little nozzle. We can click on that, and it is going to automatically put our camera in the air and point us down. We can then click on the red one for the X orientation, and that is going to have us in a side view. Same thing for the blue one for the other side. And we can basically just flip our camera around these different directions. Now, also what we can do is click on the center square. And what this center square does is it changes the perspective view of our camera, okay? Because right now our camera is working like every other camera in the world, which basically captures depth, okay? You can see if we look at the cube here, the further away from the cube we go, the smaller it gets, okay? That makes sense. But what this little button does is it can toggle our view to, instead of being perspective view, we can turn our view into orthographic. So if we click on this little cube here, as you can see, all of a sudden our view has changed and we have this sort of view now, which basically makes it so that there is no depth, okay? No matter how far away an object is, it will always remain the same size. Now, when might you want to use this? Well, typically you'd use this for 2D games because 2D games don't really have depth per se. Or if you are maybe constructing some things in your level and you want really fine adjustments and you don't want perspective and depth to get in the way of that, you can of course toggle the orthographic mode in order to get this. And also what you can then do is hold down middle mouse to sort of drag the camera around whatever plane your camera is facing. So for example, if I'm on this rotation, I go hold down middle mouse and drag, and it sort of just pans the camera left, right, up, and down, okay? So we can then click that cube again to go back into perspective mode and bring back our depth like so. And yeah, that is just a few of the controls that we can use here inside of the Unity scene view to navigate around, okay? Once more, we can hold down the right mouse button to look around. While we are holding right mouse button, we can also use the W, A, S, and D keys to fly around, like in a video game. and then we can also use the E and the Q keys to move up and down. We can also hold and drag middle mouse to sort of pan the screen around like so. And we then have the orientation gizmo over at the top right corner, which allows us to change the orientation of the camera as well as the perspective, okay, like so. And finally, if we have an object selected, we can press F on our keyboard to focus in on them. So yeah, mess around with those, get comfortable with the controls, and in the next lesson, we are going to be looking at the concept of game objects. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at game objects. Now, let's hop over to Unity and begin learning what these things are. So, with Unity, game objects are what you could call the fundamental building blocks of games, okay? Game objects are what make up all of the different entities inside of your game, okay? Everything from the lights to the cameras to the player to the 3D models of the rocks and trees, the environment itself, and everything you can interact with is a game object, okay? Now, that's quite a abstract view of what they are. So let's have a look at some examples. So in our scene here already, when we create our new project, you'll see that in the hierarchy here, we have a main camera and a directional light, okay? And these are what are known as game objects, okay? We have a main camera game object and a directional light game object. The main camera is in charge of rendering what it sees to our screen, and the directional light is in charge of illuminating the environment. Now, if you click on these objects, you'll see that in the inspector, we can see their properties, and they are sort of divided up into these individual little sections, okay? You can see if we select our directional light, you see we have this little section here called transform, which we can sort of toggle open and close, as well as light. Now, these are what are known as components, and components are what give game objects their individual gameplay behaviors, okay? At its core, a main camera and a directional light are the exact same thing. They are a game object with a name and the ability to enable it or disable it. But what makes them individual is the different components that we assign to them. You'll see that on our main camera and our directional light, they both have a transform component, okay? And every single game object has the transform component by default, and it must have it, okay? A transform component is basically the fundamental foundational component that is required, and this basically gives that object a position, rotation, and scale in 3D space. And then from there, we can add a light component, for example, to have this object illuminate stuff, which is what our directional light does. Or in the case of our main camera, we can add a camera component, which renders whatever it sees to our screen, and an audio listener component, which allows it to hear sounds. Now, let's look at some different types of game objects. What I'm going to do is I'm going to go over to the hierarchy here, and I'm going to click on this little plus icon, okay? And this allows us to create a number of different game objects, okay? You can see 3D objects, we have stuff like cubes, spheres, capsules, effects, we have particle systems, trails, lights, we have all our different types of lights, audio, video, UI. There's tons of game objects inside of Unity and even more components. So what I'm going to do is I'm going to go over to 3D object, and I'm going to create ourselves, let's just say a sphere, okay? You'll see here, what happens is when we create an object, it gets added to the hierarchy, and we can actually give it a name. So I could call it something like my new sphere. Press enter to assign the name. You can see the name does also change in the inspector here, which we can of course click to modify at any time. Now this sphere, if we select it, you can see over here in the scene view, it is highlighted and it is selected. So over in the inspector, we have the list of components which make up and basically define this sphere object. So of course we have the transform component, which gives it a position, rotation, and scale in 3D space. That is a requirement. But you'll also see that we have 3 other components, and these 3 components are there by default. You can remove them, you can add more as well. For example, the mesh filter component, this basically just defines which 3D model this sphere or this game object is going to be rendering. So if we click on the little circle next to this property here, what we can do is change it to a cube, for example. And you can see here that our object is now cube, but let's change it back to a sphere. So that's what the mesh filter does. Then we have the mesh renderer, and this basically defines all of the settings for rendering it to our screen, okay? So what material is it going to have? Is it going to cast shadows? Is it going to receive shadows? And a bunch of other lighting related settings. And then finally, we have the sphere collider component, and the sphere collider component basically makes this object solid, okay? So if we would have physics, or if our player was running around our level, they would basically hit this object and not be able to pass through it. So that is generally how a 3D model is composed with components, okay? And you can see how it differs from our directional light, for example, okay? They look totally different here in the scene view, and the sphere, of course, has a physical representation. They all are fundamentally the same thing. They are all game objects. The only difference is the components that we assign to them. And to show that even more, I can click on our sphere here, for example. We can go down to the Add Component button right at the bottom here. And the Add Component button, if we click on it, it allows us to go ahead and basically add a new component to this game object. So we can scroll through the list here, we can click Open, and you can see if we keep just having a look at these different things, there are lots and lots of different components to attach, okay? So let's just say on our sphere here, we want it to emit light. What we can do is we can just go to the search bar here and type in light. And you'll see here we have the light component. We can click on that. And now it may be a bit hard to see just because we don't really have a floor or any other environment, but our sphere is now emitting light, just like the directional light is. So you can see that we can just attach pretty much whatever components we wish to any game object, okay? If we want our sphere to be able to emit light, we can. If we want our sphere to have physics, we can attach a rigid body component. If for some reason you wanted your directional light here to have a collider, we could of course go Add Component, look for a sphere collider, and attach it like so, okay? And you can see we have this green outline of the sphere collider. Now how about removing components? Because you probably don't want a collider on your directional light. So what we can do is we can go over to the inspector, and you can see that there are these three little dots next to the component. So we can click on those and just go Remove Component, okay? If we want to remove the light on our sphere, we can do that. Or to make it a bit faster, we can just right click on the component header here and go Remove Component. And there we go. So that is a quick look at game objects inside of Unity and how they are basically made up of by components, okay? Game objects are the building blocks of every single object and entity in your game, and the components are what make those game objects individual and give them their gameplay behaviors. Thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at how we can move our game objects. Okay, so we're able to create them, we know what they are, but how do we actually move them around our scene to place them where we want them to? Well, first of all, we need to look at Unity's coordinate system, okay? Now, what is a coordinate system? Well, a coordinate system is necessary in order to pinpoint a specific position in 3D space, okay? We have a game object in our scene. Where is it? Okay, how do we define its position in our scene? Well, we do that with an X, Y, and Z value. Just like if you were to plot a graph, you need a horizontal and a vertical axis. Yet in 3D space, we have 3 different dimensions, so we need 3 axes in order to position correctly an object in 3D space. Okay, an X, a Y, and a Z value. Now, let's hop over to Unity and have a look at how we can do this. So if we select our main camera, for example, here in the hierarchy, you'll see that over in the inspector, over in our transform component, we have a position property, okay? And the position basically defines the X, the Y, and the Z axis, okay? And altogether, that is our position, okay? Now, look what happens if I change, for example, the X axis here to 1. You can see that our camera has now moved. We can go to -1 and it moves back, okay? If I change the Y to something like 3, you can see the camera moves up. Now, let's go ahead and create ourselves a game object. So I'm going to do is I'm going to right click in the hierarchy here, and I'm going to go 3D object, cube. Okay, I've created ourselves a new cube right here. You'll see that we have this 3-arrowed little overlay, and this actually looks similar to the diagram we had just in the slides. And this is what's known as the move gizmo, okay? And this basically allows us to move our object around. And you'll see that there are 3 different arrows, okay? The green arrow is basically for the y-axis, so that goes up and down. The blue is for the z, that moves forward and back. And the green and the red arrow is for the x-axis, and that moves us left and right. Now, look what happens if I click and drag on the blue arrow. You can see it gets highlighted in yellow, and I can drag it along the z-axis. And if you look in the inspector while I'm doing this, you can see that the z value of our position is changing, okay? It's in the negatives, and then we can bring it over into the positives if I drag it a bit further along. Also for the Y, we can do that as well. We can click and drag, and for the x-axis, we can do the exact same. So yeah, that is how we can move an object along its individual axes, like so. We can also go ahead and modify that directly, so I can set the x-axis in the inspector to be 0. It's going to move it over there. So if you want more precise numbers, you can do it that way. Also, in the inspector, you can hover over the individual axis headers. So if I hover over X, you'll see this little icon pops up over my mouse. I can click and drag to sort of adjust it here as well. Okay, so you can quickly adjust it just by using the inspector. Let's just say you just want to move your object along a flat surface. Well, you'll see on our object here, we have these 3 different little squares. Now, if I click and drag on the bottom one here, you can see that I'm moving the object along both the X and the Z axis. Okay, so we're moving along a single plane of direction. We can do the exact same thing for this red one. This moves us along the Y and the Z plane. And finally, the blue one, which moves us along the X and the Y plane. So yeah, those are just a number of different tools that we can use in order to position and move our game objects around in our 3D world. Now, what I'm also going to do is I'm going to right click in the hierarchy, and I'm going to create a 3D object sphere, and we can then move these objects along and just experiment with positioning them in our scene. Now, one more thing, and that is how can we delete objects? Okay, let's just say we don't want our sphere anymore. How do we get rid of it? Well, what we can do is we can go to the hierarchy, right click on our sphere game object, and then go down to delete, okay? We can also do Control Z or Command Z if you're on a Mac in order to undo your actions, or we could just click on the object and press the delete key on our keyboard, okay? So there we go. Now, in the next lesson, we are going to continue looking at how we can orientate and move these objects around by looking at how we can begin to rotate our game objects, okay? So we've looked at moving them around, but how about rotating them? Well, we'll be exploring that in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can rotate objects inside of Unity. So in the previous lesson, we looked at how we can move objects around along the X, Y, and Z positions. Now, in this lesson, we're going to be looking at how we can rotate them. So what I'm going to do is I'm going to create ourselves a new object. So I'm going to right click in the hierarchy, go 3D object, cube, to create a brand new cube right here. And to get over from the move tool to the rotate tool, what we can do is go into the left-hand side of the scene view, and you'll see there is a rotate tool button right here. We just want to click on that, and it will change. Now you'll see we now have a different gizmo appearing above our cube. And it looks a bit similar, okay? We still have the exact same colored identifiers like we had with the move tool. We have the blue here for the Z-axis, we have the red here for the X-axis, and the green for the Y-axis. Now, if I click and drag on one of these rings, you'll see that we can rotate this object around the Y-axis, for example, and you can see in the inspector that value is also changing. Now, in the inspector, this rotation value is in terms of degrees. So if I put the Y at 0, that is going to be 0 degrees along the y-axis. If I set this to 90, it is going to be a 90-degree turn. So that's why the cube doesn't look much different. Whereas if I put it at 45 degrees, you can see one of the edges is on a bit of an angle. Now we can also rotate it along the x-axis by clicking and dragging on the red, and we can do the exact same by clicking on the blue to rotate it around the z-axis, okay, just like so. And of course, you can manually assign a rotation, so we can click and drag on the little X text right here in order to rotate it smoothly, like so, or we can go in and manually assign a value, something like that. Now, also with the rotation tool right here, we can just click in the middle. So if you're not hovering over any specific line, you can just click in the middle and it will sort of free rotate around your mouse. Now, this isn't very precise, but if you just want to get a sort of random rotation on an object, you can just click and drag, move it around a bit, and then you can get a random rotation, something like that. Okay, I'm just going to undo this with Control Z. There we go, back to 0, 0, 0. And you can also see that there is a white circle surrounding it. It might be a bit hard to see, but there is a white circle surrounding all the others. And if we click and drag on that, it will rotate this object relative to where our camera is facing. Now, something else that we'll probably want to go over is the idea of world space versus local space. So let's just say I rotate this object a bit, like so. Okay, so we have it on a bit of an angle. And then I go over and press W as a shortcut for the move tool. Okay, you can also press E to toggle on the rotate tool. So E for rotate tool, W for move tool. You'll see that our move tool has now rotated along with the cube. Okay, the green arrow, which is our Y, our up and down, is not facing vertical anymore. It is now facing vertical relative to the cube's rotation. So if I go back to press E and rotate it a bit more in this direction and maybe a bit in this, press W, you'll see that our move tool is now orientated relative to the cube, okay? And we can of course click and drag to move it along that relative direction. Now, this can be great for some instances, okay, if you want to rotate an object and move it along its relative directions, but other times you might want to still move it in terms of the global direction, okay, the globally defined up, the globally defined right, and forward. Well, to change between the two, we can go to the top left corner of our scene view window and click on this second drop down where we can switch between global and local. Okay, right now we're on local, so our tools are going to be positioned and rotated relative to whatever object we are on. Whereas if we click global, the gizmos are going to be relative to the world. Okay, they're going to be based on world space rather than local space. So now we can move this rotated object along like so. We can also rotate it a bit more, and you see that the move tool does not change orientation. Okay, it sticks into its original direction and we can move it around just like before. Now also note that if you are modifying the position values, the position values here in the inspector are always in global space. So for example, if I were to move along the Z axis with the move tool, you can see I'm moving along this direction here. But if I modify the Z axis in the inspector, you can see that we move along the global Z axis, okay? So yeah, that is a look at rotating and also a look at the local and global space inside of Unity. And we'll be looking at the local and global space a bit more in detail later on once we start looking at what's known as parenting. But for now, this is the rotation tool. We can press E as a hotkey to it, or we can click on it here in the scene view, and we can rotate our objects around to whatever orientation we wish. Now, in the next lesson, we're going to finish this off by looking at how we can change the scale or the size of our game objects inside of Unity. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be looking at scaling game objects inside of Unity. So here in the editor, what I'm going to do is I'm going to create ourselves a brand new cube. And with this cube, what we can do is we can go over to the scene view here on the left-hand side and click on the scale tool right here. Okay, and this is going to toggle it. Now, it looks a lot like the move tool, yet you can see instead of arrows, we have little cubes at the end. And if we click and drag on them, they are going to change the scale of our object in the inspector. You can see that's happening along the Z-axis here. Same thing for the X and for the Y. Now, scale basically defines the size of the object, okay? Unlike rotation and position, so if I set the position to 0, 0, 0, and the rotation to 0, 0, 0, you'll see that our position is in the center of the world and our rotation is not rotated. Yet if I set the scale to be 0, 0, 0, you'll see that it doesn't exist, and that's because the default scale is not 0, rather it is 1, okay? And I think a good way of thinking of scale is in terms of percentages. You can think of the default 1 scale as 100% of its own size, okay? Because whatever 3D model, whatever sprite or effect you might have as the game object, that is going to be 100% of its normal size. So 1 is the default. And if I were to change it to be 2, then that means that this object is now twice as large, okay? Instead of being 1 size, it is now 2 size. We can bring that up to 5, and it is now 5 times as large. So scale does differ in that way, but apart from that, it behaves in pretty much the exact same way, okay? Just like when we can press W to go to the move tool, E to go to the rotate tool, we can also press R for the scaling tool, okay? And we can also click on this little cube in the middle of the tool right here, and this is going to basically scale up all of the axes uniformly, okay? As you can see here. Now, over in the inspector, we can of course modify these values individually as well. So if we want to make this cube half its normal size, we can go 0.5 on each of these X, Y, and Z axes. Now, you also see that there is this little icon next to the scale property. And what this does is it basically enables proportional modifying of these values. So if I click on it and then change the value of one of them, you can see they all change as well. Whereas if I disable it, we can also then go ahead and just modify individual axes. Because generally when you're scaling objects, you probably want to scale it along all of the axes uniformly. For example, you might have a 3D model of a tree. Now, you don't want to scale the tree along its x-axis, okay? Otherwise it would be very wide. And you probably don't want to scale it along its y-axis, otherwise it'd be stretched out. Rather, you'd probably want to scale your 3D models along all of the axes so that they maintain their proportions, okay? So yeah, bring this back to 1 here. So now that we have an idea of the movement, rotation, and scaling tools, I think it's time for a bit of a challenge. So this is the challenge that I want you to complete, okay? Using the move, rotate, and scale tools, I want you to create a stick figure as you can see here in this image, okay? It is constructed using a number of different cubes as well as a sphere for the head. So you'll be needing to create these game objects, you'll be needing to move them around, you'll also be needing to scale and rotate them as well to get them in the correct orientation and size that you wish. So have a go at the challenge and I'll be right back to see how you're done. Okay, so I hope you had a go at the challenge. Let's hop over back into Unity and have a look at how we can complete it. So first of all, we need to create our objects. So I'm going to right click on the hierarchy. I'm going to go 3D object cube. Okay, so we have our cube right here. What I'm going to do is I'm going to move it up here a bit. I'm also then going to press R to toggle the rotate, to toggle the scaling tool, and I'm just going to scale it up along the y-axis right here, okay? And this is going to be our main body. So I'm going to move that up like so. I'm then going to create another cube, but it's going to be a bit of a hassle to go ahead, create another cube, position it, rotate it, scale it. Instead, what we can do is duplicate this selected object. So with an object selected, I'm going to go Control D, and that is going to make a copy of it, as you can see. So then I can just move it over here. I can scale it down a bit, rotate it for the leg, like so. Duplicate that again, rotate it the other direction, move it over like that. Then for the arms, I'm going to duplicate the body here. I'm going to rotate it along like so, You can then also scale it down a bit, stretch it out a bit, move it up. And then what we can do is create the head. And for the head, we're just going to be creating a sphere. So I'll create a sphere like this, move it over into position. Probably need to scale it up uniformly quite a bit. And there we go. So now we have ourselves our stick figure like so. Okay, it's got its head, it's got its arms, it's got its legs, its body. And we've done this using both the rotation, movement, and scaling tools. Okay, so have a go at this, create some other stuff as well, just so you get used to the workflow of being able to move, position them. And also if you want more finer rotations, we can go over, for example, the arms here, they might not be exactly straight. So I can go over to the inspector and change the Z rotation. You can see we got an extra 0.55. I'm just going to make it -90 exactly, and there we go. So yeah, go through, create some other models if you wish. And in the next lesson, we are going to be going over the concept of parenting game objects inside of Unity. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at parenting inside of Unity. Now, also known as object parenting, this involves two terminologies, parent and child. Now, the way parenting works is that you have a parent object which can have children objects, and these children objects inherit the position, rotation, and scale of their parent. So let's hop over into Unity right now and have a look at how we can set this up. So as an example, let's go ahead and create a brand new game object. So I'm going to go over to the hierarchy, I'm going to right click, down to 3D object, and I'm going to create a capsule, okay, something like this. Now we can select the capsule, and over in the inspector we can change the name of it to be, let's just say, player, okay. This is going to be our player object for this example. Then down in position, let's set the position to be 0 on the X, 0 on the Y, and 0 on the Z, just so it's a bit more organized. Now we have our player here, right, and we can move it around like so. Now let's just say our player wants to be holding an item. This might be a piece of clothing, it might be a weapon, it could be anything that we want to sort of attach to our player. Well, for this, we can of course create another game object. So I'm going to right click on the hierarchy, go 3D object, cube, and let's rename this to be item. Now I'm going to position this as well as 0, 0, 0, move it forward a bit. I'm going to scale it down, let's just say to 0.5 for the scale, and just position it sort of like this, right? So we have our player, we have them holding or wearing an item. Now, of course, we'd want to move our player around. So we can select our player, move them around, but as you can see, the item doesn't move as well. So what we could do is, we could move the player, then move the item, but that's quite convoluted. So a way we can make it so the item follows the player is by making the item a child of the player. Okay, so how do we do that? Well, what I'm going to do is I'm going to select our item. I'm going to click and hold so that our mouse cursor changes like so. I'm then going to hover over player and let go. Okay, we're basically dragging item into player. And as you can see, something here in the hierarchy changed. Item is now indented and it is now a child of player. You can see on player it has this little drop down arrow which we can toggle to basically show and hide all of its children objects. So the item is now a child of player. So if we select the player and we start moving it around, you will see that the item basically sticks to the player, okay? It is inheriting its position. Now we can also go ahead and rotate the player, and as you can see, that cube is also rotating along with our player as if it is stuck to it. And just like with rotation and movement, we can also scale it as well, and that will scale up proportionally too. Now, how is this working and what is going on? Well, pretty much the item object, it knows that its parent is the player. So basically it sets its position to be whatever the player's position is, plus whatever offset we set here in the transform component. Okay, you can see here that the offset on the X is 0, the offset on the Y is about 0.26, and Z 0.52. Now, look what happens if I select our player and I move it all the way over here. Okay, you can see the X is like 14 and negative 11 on the Z. But if I select the item, you'll see that its X position is still 0 and the Z is only 0.5, even though we are pretty far away from the 0, 0 point in our world. And that is because this transform component is not showing its position relative to the world. Okay, it's not showing the global position, rather it is showing us the item's local position relative to the player. Okay, it is 0 units away from the player's X, and it is 0.268 units away from the player's Y origin. Okay, so whenever you have a child object, the transform component is not showing you the global values for the position, rotation, and scale. Rather, it is showing you the local values that are relative to whatever the parent object is. So if I go ahead and rotate our player around like so and scale it up a bit, you'll see that the item still has 0, 0, 0 on the rotation because relative to the player itself, it hasn't rotated at all. And the scale is still 0.5 because relative to the player scale, our cube is still half its normal size. Okay. Now, that may take some time to get used to, understanding how object parenting works inside of Unity, but it's something that you'll be using so often that over time it'll just start to click. Okay. Now, something else I think we should go over, and that is the idea of an empty game object. Now, to do this, we can just right click and go create empty. And an empty game object is pretty much what it sounds like. It is basically a game object with no components. Oh, well, we do have the transform component, but that is a necessity for everything. But there is no other components, okay? There's nothing defining what this is. And an empty game object can generally be used as the parent object for a lot of things. I generally like to use a parent game object for my player and then have the 3D model as a child, have the camera as a child, and any other items that we want the player to be holding as a child of that. Okay, I just prefer that for organization and it's generally a good workflow. Okay, so as a bit of a challenge, what I want you to do is I want you to create a sword which we can move, rotate, and scale with it all being a single unit, okay? So in this case, what we would do is we would probably have an empty game object, and as a child of that, we would have a number of different 3D models, which represents the sword, as you can see here in the image. And then by clicking on that parent, we should be able to move it around, rotate it, and it should basically act as an item that our player could use. So have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's go ahead and look at how we can accomplish it. So, over inside of Unity, what I'm going to do is I'm going to start off by creating ourselves an empty game object to sort of act as the parent, okay? Now, the reason why we're doing this is because this also allows us to decide where the origin or the pivot point for our object is. So I'm going to right click, go create empty, and I'm going to call this one our sword. Let's bring it over to 0, 0, 0 just to make it nice and organized here. And what I'm going to do is I am then going to right click on the sword. Okay, as a bit of a shortcut, we can right click on the sword object here in the hierarchy, go 3D object, cube, and that will create a cube and automatically make it a child of sword. Now, with this cube, we can resize it a bit, and I'm going to make this the handle, okay? We can then duplicate that cube with Control D. We might then drag it out a bit like so. Move it up here. Okay, and then for the blade, we can just duplicate this once more, drag it up, scale it up a bit, like so, and there we go. Okay, so we have a very basic sword right here. Now, what we can then do is select the sword parent object here, and as you can see, where the move tool is that's basically what's known as the origin or the pivot point for this object, okay? So whenever we move it, it is going to have that as the origin point for where the location is, and we rotate around that point as well. So we could then, have it as our player's weapon and then swing it around like so. And you'll see how all of the children objects follow along in suit. Now, something else I want to go over before we continue, and that is understanding that objects can have pretty much as many children as they wish, and those children can also have children, okay? So it's a hierarchy in a sense. So what we could do is we could go ahead, create our 3D object capsule once more, okay? Bring that over to 000. Let's call this one player. And what we can then do is drag the sword in as a child of player. Set the sword's position to be 0, maybe move it over here a bit, rotate it like so, and there we go. Our player is now holding a sword. It's pretty big, but there you go. And you'll see in the hierarchy that our player is the parent of the sword, and the sword is the parent of the 3 cube objects, okay? So you can basically make this tree of parent-child relationships that pretty much extend as far as you need, okay? And this sword then might have some sort of, magical effect that you might want to attach to specifically the blade and then have that as a child of the cube. And yeah, you can get into a lot of detail and have a lot of children objects of parents. Yeah, you'll definitely be going over this quite a bit when creating your games, as generally parenting is something that is used in many, many circumstances. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson, we are going to be looking at materials inside of Unity. Now, what is a material? Well, basically, materials define how an object is rendered to your screen, okay? The color of the object, the texture, the roughness, how metallic it is, and how it reacts to light. And there are many different other things that materials can do. If ever you've played a game, you would of course noticed that there are many different types of surfaces, okay? You may have water, which is slightly transparent, and it might reflect some of the light. You might have a tree, which is rough with a bark texture. Those are all materials, and those are defined by the game developers in order to tell your computer or your console how those objects should be rendered to your screen. So let's hop over into Unity right now and have a look at how we can create some materials. So here inside of Unity, what I'm going to do is I'm going to start off by just creating a brand new sphere game object. So I'm going to right click on the hierarchy, go 3D object, sphere, okay? And what you'll notice is this sphere has a pretty bland appearance, okay? It's white. You can see that the directional light over here is basically casting a light on the sphere. So it's very bright here and dark over here, okay? If we look at the directional light, you'll see the direction it's pointing with the blue arrow. And what we can actually do is on our directional light, we can go to the inspector and click on this little selection box here to basically enable and disable the light. And you'll see if I disable it, the lighting disappears. So by default, this sphere has a very simple material where it reacts to the light and it has a smooth white finish. So how can we create our own material? Well, down here in the project browser, what I'm going to do is I'm going to right click, I'm going to go up to create, and then over to material down here, okay? And I'm going to call this one, we'll just call it my material. Now, you'll see that when we create a material here, this is basically creating a new asset inside of our project, okay? This is now a file on our computer and we can use it in Unity here. So we have our material. Now let's click on it with left mouse, and you'll notice that over in the inspector, we have a lot of basically properties available to us, okay? And this is where we can modify the material. So you'll see we have things like albedo, metallic, smoothness, normal map, height map. Now there is a lot of stuff here to experiment with, but really we are only going to be focusing on the albedo and the metallic and smoothness, okay? Albedo is basically what color this material is. So if we click on this white box here, it's going to open up a little color wheel. So we can make it a red color, for example, and you'll see down here in the little preview window, we can click and drag on this to increase it in size. We have a preview of what our material looks like. So we have this red material, but how do we actually apply it to our sphere? Well, that's pretty easy. All we have to do is click and drag on the material in the project browser, and hover over our sphere and let go. Okay, we're basically just clicking and dragging it on. And now our sphere has that material. And something else that's pretty cool is anything we do to this material file right here, those changes will automatically be updated to our sphere. So let's just say we want to up the smoothness a bit. We can click and drag on this smoothness slider and bring that to 1. Okay, and you'll see right now our sphere is very reflective and it's reflecting the skybox in the background. Or if we want it to be a rough surface, maybe this is like some stone or wood, we can bring that down to 0 and it becomes a very non-reflective surface. Now, as well as smoothness, we also have metallic, which basically defines, how metal-like this object is. I'm just going to put that on 0. And something else we can also do is change the transparency of this object, okay? Because right now this is an opaque material, and you can see here, if we select our material, you'll see that we have the rendering mode set to opaque, okay? And opaque basically means it is a solid object. Well, if we click on opaque, you'll see there are a number of different rendering modes that we can choose. We have cutout, fade, and transparent. Now, if we want to be able to see through this object, we can select transparent, for example. And you'll notice that nothing really changes here. But if we click on the albedo color once more, okay, we can of course change the color just like before. But now what we can also do is go down to these 4 values, okay? And you'll see here we have the color wheel, and then we have the values RGBA. Okay, we have the red channel, which defines how red this object is. We have green and blue. And you'll see that when I change the color, those red, green, and blue values will change as well. And with those 3, that is basically how we can define colors. Now, how do we make it transparent? Well, we have one final channel here called the alpha channel, and that defines transparency. If we click and drag on this, you'll see that the sphere is becoming more see-through as I drag that down, okay? So full opaqueness at 255, and if I bring that down to 0, it's invisible, although with the transparency render mode, it does appear slightly, okay? But yeah, that is how we can use transparency inside of our materials. Okay, so as a bit of a challenge, I want you to complete these 3 materials that you can see on screen, okay? We have a reflective red material, we have a very rough blue material, and then we have a transparent green material. So yeah, have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had to go at that challenge. Now let's hop over back into Unity and have a look at how we can create these 3 materials. So first up, what I'm going to do is I'm going to create our 3 spheres. So in the hierarchy, I'm just going to right click, go 3D object sphere. I'm then going to go Control D to duplicate it and move 2 over like so. All right. Now down here in the project window, what I'm going to do is I'm going to right click, I'm going to create a new material. I'm going to call this one our shiny red. I'm going to click and drag it on our sphere like so, okay? And by default, the material that you create is going to be this white material. So it does not look like we're applying anything, but we are. So we can click on that shiny red material, go over to the inspector. We can change the albedo color to be red, and we can then up the smoothness value, okay? So it is now very reflective. So that's how we can create the shiny red material. Now, how about the rough blue? Well, let's create a new material here. I'm going to call this one rough blue. I'm going to drag it onto the middle sphere. And then for this one, I'm going to change the albedo color to be a blue color like so. And I'm going to bring the smoothness value down to 0, okay? So now it's pretty much not reflecting anything whatsoever, unlike the red one over here. And then finally, we have the transparent green color. So I'm going to create a new material. I'm going to call this one see-through green, and then we can drag that on like so. Now for this one, I'm going to set the albedo to be green. I'm going to bring the smoothness down to 0 as well. And over in rendering mode, we can switch this over to transparent, click on the albedo color once more, and we're going to bring the alpha channel down to about halfway, okay? And there we go. So if we actually move over a bit, we can see the blue through the green as well. So we know that it is working correctly. So yeah, that is how we can create these three materials inside of Unity using Unity's material system. Pretty much what we're doing is we're going down to our project browser. We are creating a new file, which is a .mat file, which is material. We are applying some changes to the list of properties here, and then we are dragging that on to an object that we want to assign. Now, a way we can also assign a material is if we click on an object, okay, and if it has a mesh renderer component, that means we can assign a material. So over here, you'll see that we have a materials dropdown. If I click on that, and we can see the material that has been assigned, okay, the rough blue. Now, we can also then click and drag on a material and drag that into the property here, okay? So if you don't want to drag that onto the object itself, or if you've selected an object that you're not sure exactly where it is, but you want to assign a material, you can just do that over in the mesh renderer component, okay? Click and drag into the materials property right here. Alternatively, you can also click on the little circle next to the material property to open up a window which basically shows you all of the materials available to you in your project. So we have our three materials right here, and we also have some other default ones that come with Unity as well. So yeah, that is a quick look at materials inside of Unity. There is definitely a lot more to them, as there are entire jobs out there in the games industry relating to materials. So feel free to explore. You can even import some textures of your own and apply them. There's lots of different ways to discover and learn about materials. So thank you for watching. Hey everyone, in this lesson we are going to be looking at prefabs inside of Unity. So let's hop over to Unity right now and get started in learning what a prefab is and how we can use them. Pretty much, prefabs are game objects that we can save to our project files and spawn them in later or create many copies of them. Okay, they're basically templates that we can use in our games. So first of all, what I'm going to do is I'm going to go into the hierarchy here. I'm going to create ourselves a brand new, we'll make a cube here, okay? And I'm going to call this one, we'll just call this one test prefab, okay? Now with this cube, I'm also going to go to our project browser and create a new material. I'll just call this one my mat, drag that on like so, and I'm going to change the smoothness down and we'll just make it red, okay? Like so. So we have this red cube right here. Now, what we can do is we can then click and drag on this test prefab and bring that down to our project window. And if we let go, a couple things are going to happen. First of all, you'll see that a new file has been added to our project browser right here called test prefab. And you'll also notice that in the hierarchy, our object is now blue, okay? It has a blue icon and a blue name. This means that it is a prefab. And down here in the project browser, we have the prefab file itself. So how does this work? Well, pretty much what we have done is we have created a template for a game object, and this blue object in our scene right now is an instance of that prefab. So let's just say we have a game and we have an enemy, right? We create an enemy game object, we set it up so that it can start chasing around our player, it has effects and everything on it. Now, what happens if we want to start spawning in a bunch of different enemies around our level? Well, we could, of course, get the game object, copy and paste it around, but what happens if all of a sudden we want to change the enemy's move speed, for example? Well, we'd have to go through each of those game objects, modifying their move speed, and, if we have a couple hundred of them, that's going to take forever. So instead what we can do is we can turn that enemy object into a prefab, and if we want to make a change to all of the enemies in our game, we only need to change the prefab, and all those changes will then get applied to every instance. So I'll show you what I mean. Down here in our project browser, I'm going to select the test prefab and drag that into our scene window. Okay, and as you can see, it has created a new game object, which is our test prefab. I'm going to drag in another one here. And there we go. So we have 3 of these cubes now. And you'll see in our hierarchy, we have test prefab 1, 2, and test prefab. And they're all blue, meaning that they are prefab instances. So let's say that we want to change the size of this cube. Okay, let's say we don't want this cube to be this size anymore. We might want it to be a bit bigger. Well, we could go through, select this prefab, select this object right here, change the scale to 1.5 a bit, select this one, scale that up, select this one, scale it up. But if we have, hundreds of objects, this might be a tree or a rock in our level where we might have, thousands of them around the place. In that case, what we can do is we can just go over to the prefab file and modify the values here. Okay, so pretty much any change we make to this prefab, those changes will be applied to every instance of that prefab. So if I go in here and change the scale to be, let's just say 1.5 on the X, 1.5 on the Y, and 1.5 on the Z, you'll see that those changes get instantly applied to these 3 cubes, okay? Because these cubes, remember, these are an instance of the prefab file right here. So they are basically looking to this prefab in order to know what they are. And any change we make to that prefab, those changes will also be applied to the instances. So again, this is just a great way of structuring your game. Whenever you start making a game and you have an object that you want basically more than one of, it's recommended that you make it a prefab, because later on, let's just say you have a door in your game, for example, and you have a bunch of doors around the place, and you're playing the game and then you decide, you know what, I want the door to open up a bit faster when the player runs through it. Well, instead of going through each and every single object that is a door and changing that value, you can instead just change one single value in the prefab, and those get applied to every instance of that door. Okay, so we can change this back to 1, like so, and of course those changes do get applied. Same thing for materials, okay? If we change the material right here to, let's just say, default-material, those materials get applied to the instances as well, okay? So any change that you make here inside of the inspector when selecting the prefab, those changes will be applied to the game object. And as well, if this game object or if the prefab has child objects, those also get assigned and applied as well. Now, what if we actually want to go ahead and edit the prefab? What if we want to maybe add more objects to it that we can't really do in the inspector here? Well, something that's pretty cool is we can just double click on our prefab and it will open up this sort of editor right here. And this is basically where we can add more objects to our prefab, change them around, etc. So in the hierarchy here, you'll see we have test prefab. I can right click on that, go 3D object, let's just say a sphere. We can then move the sphere over like so. Maybe we want this to look a bit like that. Okay, so we have a cube with a sphere. Now, if I click on the little back arrow here in the hierarchy, that'll take us back, and those changes that we made in that editor will be applied to our prefab, okay? And as you can see, each of our instances now have that extra sphere added to them. Okay, so hopefully you can see how great prefabs are, and hopefully you'll be using them throughout your entire project, okay? And they definitely do help when making your games. So, test out the prefabs, make your own, experiment with them, and thank you for watching. Hey everyone, in this lesson, we are going to have an introductory look at lighting inside of Unity. So as you can see here, I've gone ahead and just created a little environment where I've got a 3D plane with some cubes on top, and I've also applied a material to these objects as well. Now, by default, in your Unity 3D scene, you should have a directional light game object. Now, this directional light basically acts as the sun, okay? It has parallel rays of light going in a specified direction, and you can even see on these cubes here, they are casting a shadow based on the direction of the directional light. Now, if we go and press E to go to the rotational tool, we can click and drag on this directional light in order to change the direction that this light is shining, okay? And we can even rotate it up, and you can see our scene goes dark because it's basically simulating nighttime. And we can rotate that around however we like. So there you go. Now, the directional light doesn't matter which position it's in. It only really matters the direction it's facing, okay? Now, if we select the directional light and look in the inspector, you'll see there are a number of different properties in the light component. For example, we have the color, which we can select and modify on the color wheel right here. We can have a green sun, for example. We can have a blue one. We can have a pink one. You can really change it to whatever color you wish. We also have the intensity, which defines how intense our light is. As you can see, I can bring that number up and it gets very bright. We also have shadow type, so we can change our shadows from being soft shadows to hard shadows, which may run a bit better on certain devices, and no shadows if you want to have no shadows available, which could help with performance. I'm going to swap that back to soft shadows. And then there are some other options as well, but lighting can be a very advanced topic if you go deep into it, so we're not going to look too much into that, okay? But as well as directional lights, Unity also offers a range of other types. So if I right click here in the hierarchy, I can go down to light, and you'll see here we have some others, okay? We can select point light, and this basically is a light source that emits in all directions around it. So something like a candle, for example, would have a point light like this. You can move that around and you can see the light changing as it goes. Let's change the color. Actually, let's make it a candle. So let's change the color to an orange. We might want to then up the intensity a bit. And with the point light, we also have a range property. And if we zoom out a bit, you'll see that there is this circle around our point light. And that basically defines the range of the light. Now, if we go to the edge where we have these little cubes, we can click and drag on those to increase or decrease the range of our light, or we can change the range property here in the inspector. Okay, so that is the point light. Let's move that over there. And the next light that we're going to be looking at is the spotlight. So we can right click in the hierarchy, go light, spotlight, and this is something that you would use, for example, if you have a torch or something that you want to cast in a certain cone. So you can see the spotlight has a cone that emits from its position, and the rotation determines which direction it is facing. So with the spotlight, we can rotate it. We can go over and click and drag on these little cubes at the end of the cone to increase the angle. We can even increase the range of it as well here, or we can do that over in the inspector respectively. We can change the color, so we might want to make this a green light, change up the intensity a bit, and yeah, basically, there are lots of ways to set up lighting here inside of Unity. These are probably the most common ones. A directional light, if you're having an outdoor setting, you'll most likely have a directional light. If you're indoors, then you might have point lights lighting up your environment, as they might be in light bulbs, or they might be candles or flames. And if maybe you have a street lamp, or you have some cars, or your player is holding a torch, then you might use something like a spotlight. So yeah. That is just a basic overview of lighting inside of Unity. One thing to be wary of though is a lot of lights can impact your performance, and generally lighting is one of the most performance heavy things that you can have in your game. So do keep an eye out for that, but generally it should be pretty good if you go light on the lights. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at physics inside of Unity. So let's hop over to the engine and begin to have a look. So in Unity and many other game engines, they have physics capabilities, meaning that the things and elements and game objects in your game can interact with each other with physics. So if you would have a hill, you'd be able to spawn some spheres and have them roll down, okay? So things like gravity, friction, velocity, and various external forces can be applied to your objects. So how do we get this working in Unity? Well, to start, I'm going to go ahead and create a new 3D plane, which is basically a flat ground. So I'm going to bring this to 0, 0, 0 here. So we have a flat ground. I'm also going to go ahead and create a material just to make this look a bit different. Just call it ground, drag that on. Set the albedo to a darker color, like so. Bring the smoothness down. And now I'm going to right click. I'm going to create a new 3D sphere. And I'm going to move it to the center here. Now, when we press play, we're going to switch over to our game camera. So let's actually orientate this in a position that we want. So I'm going to move it up about here. There we go. So we have our sphere. Now, if I go ahead and click on the play button, what you'll see happen is not much, okay? It just sits there because it is a game object. It doesn't know what to do. It's just a sphere sitting there. So what we can do is attach a component that gives this sphere physical capabilities. And to do that, we can go down to add component once we have the sphere selected. And we are going to add in a component called a rigid body. So select that. Let's actually close up the mesh renderer here and the mesh filter since we won't be needing those. Now, the rigid body component basically applies physics to the game object, okay? You can see here we have properties for mass, drag, angular drag, whether or not we use gravity. So if we go ahead and press play, what we should see is the ball then falls to the ground. As you can see, it's sitting on the ground. So the way this works is with a sphere collider, okay? It's important that if you do have a rigid body component attached, that you also have a collider component as well, because if your object doesn't have a collider, then there's no real point of it being a rigid body, right? Because it's not going to be ever able to hit anything or roll or have friction. So the sphere collider is basically what defines the physical boundary of the sphere. If we go to the scene view here and go in a bit, you'll see we have this green wireframe around, and that is the sphere collider. We can increase and decrease the radius of that if we wish. So if the 3D model is a bit not exactly to fit, we can change the sphere collider to match that. And the rigid body applies physics. So let's just say we want our sphere to roll down something. Well, what we can do is we can create a brand new cube here. Okay, I'm just going to make a nice simple little ramp. So I'm going to bring this underneath our sphere. I'm going to scale it a bit like so, and then rotate it like that. Okay, so we have this nice little ramp. So now if I press play, what you should see is the sphere hits the ramp and it rolls down the hill and then off the edge. Okay, so that works. Now, something else we can do on our sphere is change its settings, okay? Things like drag. Now, drag basically determines the wind resistance on this object. At a drag at 0, that basically means we're in space, and if you apply a force to an object, it is going to maintain that velocity until something else changes it, okay? Because drag isn't going to slow it down. Whereas down here on Earth, if we were to apply a force to something, like throw a ball, that of course would be affected by gravity, but the speed would also be affected by wind resistance, okay? The wind hitting that object and slowing it down. So for the drag, we can set this to, let's just say 1. And what we should see is that this ball is all of a sudden going to roll down here, and just before it gets over the edge, it stops, okay? Because that momentum has been slowed down by the drag. So that is one way we can apply physics to an object. Now, there's also a bunch of other stuff here, such as interpolate, collision detection, but these are for more advanced things, such as maybe player controllers, which we're not going to be looking at. There's also a constraints tab here, and this allows us to freeze the object along its positional axes as well as rotational axes. So let's just say you want to have a physics object, but you don't want it to be rotate, okay? You might be making a player that you want to jump around, but you don't want the player all of a sudden to just fall over on its side when it hits a little bump, okay? In that case, you'd probably want to freeze the rotation along these axes here. But we don't want to do that since a ball, it needs to move in 3D space and it needs to roll. Now, the physics is also pretty realistic, so we could go ahead, duplicate this ball a bunch of times like so, and just see what happens, okay? So we have a bunch of those there, press play, and we should see them all interacting with each other like so. And yeah, it can be pretty fun to mess around with Unity's physics, adding in your own sort of things, maybe eventually have a player running around, hitting boxes, as it's always great to have physical interactions like this within your games. So yeah, that is just a quick look at the rigid body component, which applies physics to our game objects. You can also do the same for cubes and for any other object that has a collider attached, okay? It's important that your rigid bodies have colliders because otherwise they're not really going to be interacting with the world at all. So yeah, thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to have an introductory look into scripting. Now, scripting is a very important part of the Unity game engine, and it's basically what allows us to create our games. So, what is scripting? Well, basically it's how we create the gameplay behaviors and logic for our games. Now, scripting, it can also be known as coding or programming. Generally, those words can be interchangeable, although they do have their own specific meanings. But generally, when somebody says they are coding in Unity, that normally means they are scripting or they are programming. Okay, this is basically coding. We are writing code to give instructions to the game engine in order for it to do certain things. Okay, now a script is a file that we can create which contains code. Okay, think of like creating a new Word document or a new Notepad document. It is a file which contains the text of the code that we have written. So if we, for example, want to create a player controller which moves our player around, we would create our player controller script, and in there we would code all of the behavior for that player. Now, it's also important to note that a script is essentially a custom component. Okay, we are basically creating our own components inside of Unity whenever we create a script. So that means we have the ability to attach our scripts to game objects. Okay, so in the case of that player controller, we would essentially attach it or add it to our player game object, and then that script can basically interact with that game object, moving it around, and also maybe even communicating with other components that the player might have. Now, let's hop over into Unity and look at how we can create a script and how we can add it to a game object. So here I am inside of Unity. Now, the first thing we want to do is to go down to our project window here. And what I'm going to do is I'm going to create a script. So what we need to do is right click in our project window, go up to create, and you'll see here at the top it says C# script. So I'm going to click on that and you'll see it creates a new file. We can then give it a name here when it is highlighted. And I'm just going to call this one my first script, or you can really call it whatever you wish, and then hit enter and it will create it. Now, what is C#? Okay, and you'll see we also have this hashtag or pound icon on the file, and C# is essentially the programming language that Unity uses to write its scripts. Just like you have English, French, or German, there are many different types of programming languages, okay, or coding languages. And Unity specifically uses the C# programming language for us to write our scripts, okay? And that is what we are going to be looking at for the rest of the course. We're looking at how we can start writing code and get a better understanding of the C# language and how we can interact with Unity in order to make our games. So, we have our script file right here. Now, what can we do with it? Well, we could open it up and start writing code, but before we do that, let's go and look at how we can add it as a component. Now, basically, once we create our script, it is essentially all done for us, okay? It has automatically been added to Unity's list of components. So what we can do is if we go over to our hierarchy, I'll right click and create a new 3D cube here, okay? And all we need to do is select the cube, and just like adding any other component, it works the exact same way. So we can go to the inspector, go down to the add component button, and what we can do then is we can of course go through our list of all the components, or we can go to the search bar here and type in my first script, and here you'll see it pop up. We can click on it and my first script will be added as a component, okay? So we can open and close it, we can enable and disable it, we can even right click and remove it, okay? It's basically a component that we have created. So we can also click and drag on the script file and bring that into the inspector to attach it like so as well, okay? So generally, if you don't want to go through the add component button, you can just click and drag your script onto a game object to add it quickly. So we have our component created. Now, how do we actually start writing code for it? How do we start writing logic so it can do something? Because right now, if we were to press play at the top here, we'd press play and nothing would happen. And that is because the script is basically empty. It contains no code, no logic. So how do we start writing that? Well, we just need to go down to our script file right here and double click it. And what that should do is open up the Visual Studio code editor, okay? Now, there may be an initial setup that you need to do where it may ask you to log in, and you can of course then log in with a Microsoft account or any other account that it provides. And once that script opens up, you should have Visual Studio open like so. Okay, yours may look a bit different just because I've changed the layout a bit, but generally you should have this program open. It may prompt you to log in. If so, just go through that process. And once it opens up, we should see our code right here. Now, Visual Studio is essentially a development environment, okay? This is a program which specializes in writing down code. Now, you could, for example, have Notepad or Microsoft Word as your code editor, yet that would be not a good idea because a program like this specializes in making writing code as easy and as comfortable as possible, okay? Things like autocorrect, automatic formatting, and coloring the bits of code to make it easier to read are just a few of the affordances that a program like this provides. So, initially, we'll see this bunch of code right here, okay? Things like using system.collections, public class, void update. Initially, you're going to look at this and have no idea what any of it is, and that's fine, okay? When starting out, code can be quite daunting, but what we're going to do in this course from here is go step by step, looking at the very basics, the foundations of programming and understanding the logic behind it so that we can then start creating our games, okay? And for most of this course, we are going to ignore a lot of this stuff here as that's really just a lot of the boilerplate stuff that we need in order to structure our script here. For now, we want our script or our component to actually do something. So what I'm going to do is I'm going to go over here to where it says void start. Okay, you see it says void start, and then it has these two little brackets, and then these squiggly brackets right here. Now, we're going to be going over this in a later lesson, but this is essentially a function, and it's basically a block of code which can run whenever we want. And you'll see after void start, it has these two squiggly brackets, and basically in between them, we can write some code. Now, the start function basically gets called once at the start of the game. So when this object is initialized, the start function will be called. So what I'm going to do is inside of start here, between the opening and closing squiggly bracket, what I'm going to do is I'm going to select. You should see it's automatically indented a bit as well. And I'm going to write debug.log. Now you should see when you're typing it, it pops up with this autocorrect window. So you can just hit enter and it will autocomplete whatever you're writing. And then in two brackets here, I'm going to put two quotation marks and just write hello. Okay. And then at the end, I'm going to put a semicolon to end that off. Now, looking at this, it's probably confusing. What's debug? What's log? Why do we have to put a semicolon here? We'll be going over this a bit later on, but for now, let's just get something working, all right? So debug.log. What we can do is we can go then Control S, or you can click on the little save button up here to save the script. We can then minimize this window and return to Unity. Okay, now nothing looks different. Our script is still here, but if you select the script, you'll see in the inspector we have a little preview of it, and we can see that that debug.log line is there. Now, if I press play, what you'll see is down here in the console, we have a new message, and that's because debug.log is essentially a line of code which allows us to print messages to our console, okay? So this basically allows us to see if the code works, and since it says hello down here in the console, we know that our script is working and it is running. So that is an introductory look at scripting inside of Unity. And in the next lesson and for the rest of the course, we are going to be going over the different fundamentals of programming and interacting with the Unity engine. So thanks for watching, and I'll see you all then. Hey everyone, and welcome. In this lesson, we are going to begin creating our balloon popper game. So to begin, we need to go ahead and create ourselves a brand new Unity project. Here inside the Unity Hub, we can go over to New, and I'm going to just go ahead and I'm going to call this one, let's just say we're going to have Unity Micro Projects, all right? Make sure it is a 3D template. You can choose a location where you want to save your project files to, and then we can click Create to, of course, create the project and open up the Unity editor. Okay, so here we are inside of Unity. Now the first thing we're going to do is I'm going to go ahead and create a brand new folder here inside of our project browser, and this folder is going to be called Balloon Popper, okay, because we are going to be creating various different projects in this course. The first one, of course, being the balloon popper. So we're going to make an individual folder for each just to organize them a bit easier. And then inside of the balloon popper folder, we are going to create a new scene for the balloon popper game. So we can right click, create scene, and this one is going to be called balloon popper, like so. We can then double click on it to open it up, and you should see here in the hierarchy, we have the little scene icon and it says balloon popper. Okay, so we're inside of the scene now. Now let's set up the main sort of mechanic of our game, which is going to be clicking on the balloons in order to pop them. So how do we create our balloon game object? Well, for this, what we're going to do is we are going to just go into our hierarchy here. We're going to right click and go down to 3D object sphere. Okay, we're just going to keep it nice and simple. We're just going to have a sphere as our balloon. And of course, let's give this a name of balloon. There we go. Now over here in the scene view, we can of course move our camera around and get closer to our ball, or we can press F to focus in on it automatically like so. Make sure that over here in the inspector, your position is at 0 on the X, 0 on the Y, and 0 on the Z. And if you click over into the game view tab, you should see that the balloon is nice and centered on the screen, okay? So now what we can do is let's give it a material, because right now we just have this plain white balloon and, you know, it doesn't really pop. You know, balloons generally have colors. So down here inside of the project browser, I'm going to right click, create, go material, and this one is going to be called, we'll call this one red balloon. Okay, we'll go over to the scene view here. Let's drag this red balloon material onto our sphere, like so. Now nothing's changed, and the reason why is because if we click on our material, over in the inspector, we can modify the properties, okay? What sort of material is this going to be? So over here, what we want to do is change the color. Now to do that, we need to go over to the albedo, which is basically the base color of the material. And you'll see to the right of it, we have this little color selection box. Okay, we're going to click on that. And then this window will appear where we can select a color, okay? Just your standard color picker that you've probably seen in other pieces of software before. So we can go over here, we can get a nice reddish color like that. There we go. Look in the game view, and there we go. We now have our red balloon. And we can also modify other properties, such as the smoothness, which is at 0.5 right now. And you can see that the smoother I make it, the more sort of reflective the balloon is, okay? Or we can bring it all the way down to make it a nice sort of matte colored red. Or all the way to 1 to make it a reflective sort of surface. Now, balloons aren't too reflective, although they are kind of, so I'm just going to set smoothness to be 0.5, okay? Just the default. And there we go. Now, as a bit of a challenge, I want you to go ahead and duplicate this balloon. So let's go ahead and do that right now real quick. Okay, so I'll just move this over. Control D or Command D on a Mac. Drag it over here. Do that again. And look in the game view, make sure that you can see them on the, on the same row here. You might need to move them around a bit in order to get that perspective right. And what I want you to do is I want you to go ahead and create a material for a blue balloon and a green balloon material, okay? So create those two new materials and apply them to the other balloons right here. So I'll be right back to see how you're done. Okay, so I hope you had a go at that. Pretty much what we need to do is go back down to our project browser, and I'm going to right click, go create, material, and I'm going to call this one blue balloon. Okay, scene view, drag that onto the middle one here, and I'm going to set the albedo for this one to be a bluish color, something like this. There we go. And then finally for the last one, we need to create a material, call this one green balloon, assign that to the other balloon at the end here, set that color to be green. And there we go. So now we have our 3 different balloons of 3 different colors. Now in the next lesson, what we're going to do is set up our balloon script so we can finally start clicking on them to make them bigger, and then once they reach a certain size, they will pop. And then alongside that, we're also going to have another script which manages our score, okay? So each time we pop a balloon, a certain number will be added to our score, and then eventually we'll have some text on screen displaying that score. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to continue on with our balloon popper game by adding in a balloon script which is going to be able to detect clicks and increase the size of the balloon. Once it reaches a certain size, it will then pop and add score, which we can then have displayed on screen. So to do this, let's start off by going down to our project browser here. I'm going to right click, go create C# script. Let's call this one balloon. And what I'm going to do is over in our scene view, let's select all three of our balloons here. So hold down shift and click on each of those to select all of them. You should see here in the hierarchy. And I'm going to drag on the balloon script right here to the inspector to add it as a component. So each balloon now has the balloon script component. We can then go ahead and double click on this balloon script here to open it up inside of Visual Studio. Okay, so here we are inside of our balloon script. Now let's have a look at the different things that are already here by default. First of all, at the top of the screen, you'll see we have these using things, great, okay? Using system.collections, using Unity Engine. Basically, these are all of the libraries that we are accessing, and a C# library is basically a bunch of code that we can implement in order to do certain things. For example, using Unity Engine allows us to access a lot of the Unity related functions. And then over here we have public class balloon. Public class is basically defining this as a class balloon, which is the class name. And you'll see here we then have a colon mono behavior. And this here is basically which class we are inheriting from. So which class are we inheriting variables and functions from? And that is mono behavior. And mono behavior is a class which basically allows us to connect this script as a component, allows us to attach it to a game object. And then down here inside of the class, we have two functions already set up for us. The start function right here gets called at the start of the game before the first frame, and update gets called every frame. Now for this balloon script, we don't want to do any of these, okay? So let's select both the start and update functions and just delete them. And now what we want to do is instead we want to create a function called void on mouse down. Okay, and on mouse down is a function that is built into Unity. Okay, it's built into mono behavior right here. And you want to make sure that it is spelled correctly, okay? On mouse down, capital letter for each word. And you'll see here that it is being highlighted in blue. And on mouse down, if you hover over, you'll see here that it says on mouse down is called when the user has pressed the mouse button while over the GUI element or collider. So when our mouse is over this object's collider and we left click, this function gets called. Okay, so what we want to do on here is basically increase the size of the balloon and then pop it when it's ready to pop. So how do we know how much score we want to give, how big we want to make the balloon, and how many pops we need to click? Well, for that, we are going to be creating some variables. Okay, and variables are basically pieces of data that we can assign to a class and it can hold information. So here I'm going to go public int for score to give, and we'll give it a default value of 1. So basically what we're doing here is we are defining the scope of the variable. Public basically means it can be accessed inside and out of this class, and it's also being displayed inside of the inspector, so we can modify it there on the component. Int is defining the data type, which is of type integer, so a whole number. We then give it a name, and then optionally we can assign a default value, which we have done here with 1. The next variable is going to be a public int for clicks to pop, and we'll set that to be 5 by default. Clicks to pop is basically how many times we need to click on the balloon to pop it. Okay, score to give is how much score we are going to add, and clicks to pop is how many times we need to click on the balloon. And then what we need to do is we need to create a public float scale increase per click. And I'll set this by default to be 0.1. Now, float is a floating point number, so that basically means a number with a decimal. We're calling this one scale increase per click. This is how much we're going to increase the balloon's scale by each time we click on it, so it gets bigger and bigger. And the default value is 0.1. Okay, so we're increasing it by 0.1 each time we click on the balloon, and this F at the end just defines this number as a float. Okay, so whenever you want to write down a float, you do need to put an F behind it. Now, what we can do is go down here to on mouse down, and first of all, we click on the balloon. Let's subtract 1 from clicks to pop. Okay, so to do that, we can go clicks to pop minus equals 1. Okay, so we are subtracting 1 from clicks to pop. Then what we need to do is increase the scale of the balloon. Now, to increase the scale of the balloon, we need to access this object's scale property. Okay, so if I save this script real quick and return to Unity, let's go over here and click on a balloon. You'll notice that the component has all the properties here, so we can modify them if we wish. But the property we want to modify is scale right here, okay? So we have X, Y, Z on the scale, and you can see how when I increase the scale along the X, the Y, and the Z, it basically makes the object larger. So to do that, we need to access the transform component. So for this, we can go transform.local scale, which is the property that modifies the scale. And then we want to go plus equals vector3.1 multiplied by scale increase per click. Now, a vector3 is basically a piece of data that contains an X, Y, and Z value. And vector3.1 is a sort of preset vector which has 1 for the X, 1 for the Y, and 1 for the Z. So if we multiply that by scale increase per click, we're basically increasing our X, Y, and Z scale by 0.1. Okay, so that's what this line of code here does. We're increasing our scale by this much right here each time we click. So let's save this script, return to Unity, and test it out. So let's press play, and if we click on a balloon, you should see, there we go. I'm clicking on it, and we can make it as pretty much as big as we want. If we stop playing and we click on the balloon, let's change the scale increase per click from 0.1 to 0.5. Let's make it a bit bigger. We'll press play. And now if I click on it, you'll see that it is increasing at a much larger scale here. And if we look over at the top right corner, you'll see the scale variable here is at 5 right now. I click on it, 5.5, 6, 6.5, and it keeps on getting bigger. But there is a problem, and that is that we can keep on clicking on this balloon forever, and it's not popping. So first of all, what I'm going to do is I'm going to change the scale increase per click back to 0.1. And in the next lesson, we are going to be working on actually popping this balloon and adding our score. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to continue on with our balloon popper minigame. So what we're going to do now is start working on being able to pop our balloon and add score to it. So to do that, what we're going to do is we are going to first of all go down to our project browser, and we are going to create a brand new script. And this one is going to be called Score Manager. Okay, just like so. So with our Score Manager, we need to attach it to a game object in our game. So to do that, I'm going to right click in our hierarchy, and I'm going to create empty. And what create empty does is basically creates a game object with no components. And I'm going to call this one Score Manager. Now, if you have scripts that aren't really modifying the position or modifying anything attached to that game object, then generally it's good to attach it to an empty game object to act as sort of a container for management scripts. So there we go. Then what we can do is open up our Score Manager inside of Visual Studio. And this Score Manager script, we can delete these start and update functions since we won't be needing those just yet. What we're going to do is we are going to create a variable. And this variable is going to be a public int for our score. Now, this is going to be the variable which keeps track of our total score. So whenever we pop a balloon, this is going to increase. So how do we increase the score? Well, for that, what we're going to do is we are going to be calling a function on the Score Manager. So if we go to a new line, what we're going to do is we're going to create a function called increase score. And it's going to have a parameter. So it's going to have an input into the function where we can send data into it. And it's going to be of type integer, and it's going to be called amount. So all we want to do inside of this function is just go score plus equals amount. So when this function right here is called, we're going to be sending over an amount and that amount is going to be added to our score variable right here. Now, where and how do we call this increase score function? Well, in order to call it outside of the script from the balloon script right here, we need to make this variable public. Or we need to make this function public, I mean. And to do that, it's the exact same way as making a public variable. We just need to add the keyword public behind it. Now, if we weren't doing that, and if we just had void, then that means it is a private function. And a private function can only be called within the script or within the class that it was created. So we won't even know that this function exists over here in the balloon script unless we make it public. Okay? So now what we can do is go over to our balloon script, and we need a way of calling that function. So how do we do that? Well, in order to do that, we first of all need to have a reference to the score manager component. And to do that, let's create a new variable here. It's going to be public score manager, and we'll call it score manager. Okay, so the type of variable is going to be this score manager component, okay, or the score manager script right here. So if we save this script, go back into Unity, what you'll see is if we select on one of our balloons, you'll see over here that on our balloon script, we have a score manager property. And what we can then do is drag in our score manager game object. It's going to assign that component to that property right here. Let's do the same for our other balloons. Drag in the score manager like so, because on our score manager game object, we of course have the score manager component, okay, right here. So now what we can do is inside of our balloon script, we can check to see if our clicks to pop is equal to 0. Okay, so here, I'm going to, at the bottom of this function, I'm going to go if clicks to pop equals 0. So if the clicks to pop is equal to 0, then we are going to increase the score. So to do this, we can go score manager dot increase score. You can see here we can access that function, and we're going to be sending over the amount, and the amount is going to be score to give. Okay, this variable right here. And then finally, once we pop the balloon, we want to of course destroy it. So to destroy an object inside of Unity, we can just call the word or call the function destroy. All right, sending over the game object we want to destroy, which is going to be game object. Make sure it is a lowercase g, capital O, and this word right here basically refers to this game object, okay? The game object that this script is attached to. So we can save that, we can return to Unity, and what we're going to do is we're going to select our score manager and keep an eye on this score property right here, okay? Let's see if it goes up. So I'm going to press play, and let's click on the red balloon. You can see once it popped, it got destroyed, and score is now equal to 1. Let's do the blue one. There we go, score is now equal to 2, and for the green, score is now equal to 3. Okay, so you can see it is increasing right here, which is pretty good. Now on our balloons, we can of course change the score to give property. So on the blue balloon, let's set this maybe to, we'll go 2. And on the green balloon, we'll set it to be 3. So the red balloon gives us 1 score, blue gives us 2, and green gives us 3. So if we select our score manager again, and if we pop the red balloon, there we go, score has been increased by 1. Click on the blue balloon, there we go, score has been increased by 2, and finally, once we pop this green balloon, our score should be equal to 6, okay? 3 plus 3 is 6. And there we go. Our score is increased by 3 again. So yeah, that is how we can pop our balloons and also communicate with other scripts inside of Unity, okay? Because once it comes down to actually creating games and creating all these interacting systems, you will be having different components, different scripts communicating with each other, okay? And this is just an example on how to do that. We have our balloon script, which is communicating to our score manager when it gets popped, and it's calling a function on the score manager when it gets popped. Okay, so in the next lesson, what we're going to do is we are going to be looking at Unity's UI system, and we are going to be setting up some text here to be displayed on top of the screen, okay? And that is going to be our score text. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at Unity's UI system in order to create some text on top of our screen. So what we're going to do first of all is let's hop over into our scene view right here. Okay, and we need to create something known as a canvas. Now, a canvas is basically going to be the container which holds all of our UI elements. And the canvas can change size based on your screen's resolution and aspect ratio, thus having the elements inside of it react based on that. So what we're going to do is in our hierarchy, let's right click and we want to go down to UI, and then you see here there's a lot of different UI components we can choose from, but we're going to go down to canvas, okay? And as you can see, it's created two new game objects. It's created a canvas, which if we look over here, you can see it is very, very large. And it's also created an event system. Now, an event system is basically a component which allows us to interact with UI objects. So if we click on a button, if we drag a slider, this is basically going to be in charge of that. So it's good to have an event system here, and luckily it gets created automatically for us, so we don't need to touch any of this. Now let's select our canvas right here, and you'll see over here on the right hand side we have a number of different components. Now first of all, you may notice that our transform component is missing, or more so our transform component has been changed to something known as a rect transform right here. Now, a rect transform is basically the replacement for a transform component that each UI object has, okay? So our buttons, our text, any sort of UI element you want to add to a canvas will have a rect transform component. Now, this is different to a normal transform component. You'll see here that it does have position, X, Y, Z, it has scale, it has rotation, but it also has width, height, pivot, and anchors, okay? The width and the height, that's pretty self-explanatory, basically how wide and how high in terms of pixels is this UI element. Anchors and pivot, we'll get to that in just a second. So we have our canvas right here. Now to get in a bit of a better position for working with it, what I'm going to do is go over to the top left corner of the scene view, and you'll see here there is a button that says 2D. I'm going to click on that 2D button right now, and you'll see it turns us into this 2D mode. So we can zoom out, we can hold right mouse to pan around, but I'm going to click on our canvas and press F. And as you can see, we have now focused on our canvas right here. So we can zoom into it, but there's nothing on our canvas just yet, so nothing really to modify here. So let's add in some text. So what I'm going to do is I'm going to right click on the canvas game object in the hierarchy, and I'm going to go down to UI, text mesh pro. Okay, you see there is one that says text, but we don't want to do that. We want to go down to text mesh pro and click on that. Now this window is going to pop up. You just want to click on the import TMP essentials. Now text mesh pro is basically a package that comes with Unity. It used to be a third-party asset that you could download from the asset store, but in recent years Unity has sort of integrated it within the engine itself, so it's now a part of Unity. And Text Mesh Pro is basically a really good way of displaying text in games. Rather than having a text being made up of a bunch of pixels, it's instead made up of a mesh, which allows us to get really fine and crisp text. Okay, but we don't need to worry about all that. We can then exit out of the TMP importer window right here, and you'll see in the middle of the screen we have our text element. Okay, you see it has the rect transform component, it has a canvas renderer component, which is basically there to render on the canvas, and it has a text mesh pro -text component, which has all the different properties that we can modify. So if we zoom into this text here, you'll see a number of things. First of all, we don't have the XYZ move gizmo ready to move it around. Rather, we have this new tool, which is the rect tool up here at the top left. Okay, of course, we can switch to all the old ones. We have the move tool that we know here, but the rect tool allows us to modify the width and the height of this object. So we can just click and drag on this object here to move it around our canvas. And you can see here that if we bring it to one of the edges, it will snap into place. So finally adjusting things and snapping together is really good with Unity's UI system. You can even see it snaps directly into the middle as well, along the horizontal and vertical axes too. And these blue circles on the four corners allow us to click and drag to resize this element, okay? So if we want a larger text area, we can of course make it bigger. We can also click and drag on the sides here. You don't want to click and drag on these little white cubes though, as they do increase and decrease sort of the margins. So we don't really want to modify those. Rather, we just want to click and drag on the vertical lines and horizontal lines. Okay, so I'm going to make a text box about this big, I'd say. We can then drag this to the top of the screen since that's where we want our text to be displayed. Okay, there we go. And if we look into our game view now, you'll see here that the text is being displayed on screen. Okay, so let's get to actually creating our text. I'm going to first of all rename this game object to be score text. Okay, and then let's give it some placeholder text to just display. So down here where it has new text, we can rename this, or we can change what is being displayed. So what's going to be displayed is just going to be score, we'll put a colon, and then we'll just have an example of, let's just say 500. Okay, there we go in the game view. Then we can modify the properties down here. There are a large number of different text properties inside of Unity. We can make it bold, we can make it italic, underline, all these different things here. We can increase and decrease the font size. So let's maybe increase the font size to about 40, or make it bold. We can change the vertex color, which is just the color of the text. Let's make that a sort of darkish color like so. If you look in the game view, that's what it looks like. Okay, we can also set the alignment. So down here, we can align it to the left by default, the middle, the right. I'm going to align it to the middle, and then we can also do the same vertically. Okay, top, middle, bottom. I'm going to align it to the middle. Okay, so now the text is centered within this, within the bounds of its object. Okay, there we go. We don't really need to worry about any of the other things down here. These are more material related aspects. But what we can then do is look at the anchoring. Now the anchoring is what allows us to have dynamic UI that changes based on the resolution of the screen. So if we go into the game view right now and we sort of undock the game window, okay, just drag it out, you'll notice that if I resize the game view, you'll see that the score text is sort of staying in place, okay? It's not moving with the screen. But what we want to do is sort of attach it to the top of the screen. So when we make the screen really small like this, the score text is just underneath the top of the screen. And when we make it really tall, we also want the score text to be there as well. We don't want the score text to sort of sit in place like it is right now. Okay, and the reason why is if we dock this back, the anchoring is set to center. So as you can see right here, we've got this little thing inside the rect transform. If we click on it, you'll see the anchoring is set to middle center. This basically means that the object is going to remain at this specific distance in terms of pixels from the center of the screen. But what we want to do is set the anchoring to be at the top center. So to do that, we can select the anchor gizmo here and just set it to be top center. And you can see that the 4 little anchor arrows have also moved to the top center of the screen here. So now we can undock the game window, and if we resize it, you can see that the score is remaining at the top of the screen. If we make it very tall, if we make it very squat like this, you can see that it is still remaining on screen at all times. That is because it's basically attached to the top of the screen, and it is always going to remain a specific pixel offset from the top. Now, in the next lesson, we're going to look at actually implementing this text into our score manager and being able to modify it inside of the script. So thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be connecting our score text right here to our score manager script. So let's open up the score manager right here inside of Visual Studio. And first things first, we need to create a variable that references the text component, okay? If we want to actually access it and modify what it is being displayed, we need to access the text component. Now to do this, we first of all need to go to the top of the screen here, and we need to be adding in using TM Pro like so. Okay, TM Pro is basically Text Mesh Pro's library, which allows us to access the different classes that we need. Okay, so down here then, inside of the score manager, let's create a new variable. This is going to be called public, and it's going to be of type text mesh pro UGUI. Okay, it's a pretty long data type here, or pretty long class. And I'm going to call this one score text. Okay, just like so. Now, as well as this, we need to also create a function which updates the score text to display the current score. So to do that, we can go void update score text. And inside of this function, what we're going to do is go score text dot text. Okay, the dot text is the property which allows us to modify what gets displayed. And this is just going to be equal to, and I'm going to make a string here. So we're going to go score colon, I'm going to put a space, and then we can combine this string with a number. So we can combine it together by going plus score. Okay, and what this will do is basically have the text display score colon a space and then however much score we have. Now, this update score text function does not need to be public due to the fact that we are only going to be calling it within this class here. So where are we going to be calling update score text? Well, first of all, we want to call this function whenever we update our score. Whenever we increase our score, we want to call it. So after we add the amount to our score, we want to call update score text. And then we also want to call it at the start of the game, okay? Because right now we have the placeholder 500 on our score text. We, of course, want to set that to 0 at the start of the game. So up here, I'm going to create the void start function, okay, which gets called once right at the start of the game. And inside of here, we just want to call update score text, okay, just like that. And this should be all the code necessary in order to update our score text when we increase our score as well as at the start of the game. So back inside of Unity, what we're going to do is go over to our score manager object right here. And on our score manager object, you'll see here, of course, we have the score text component. We can drag that in. There we go. Press play, and we should see that score is 0. Now, if we pop some balloons, there we go, 1, 3, and we should then see 6. And there we go. So you can see the score text is being updated, so it's working just fine. Now from here, pretty much what you can do is go ahead and duplicate a bunch of these balloons, start placing them around the screen. Also, if you wish, you can create new materials. You can set, different types of balloons which have different amounts of clicks required to pop them, different amounts of score they give, different scale increases as you click on them. So yeah, good luck with that. And throughout this project, we pretty much looked at working with multiple scripts and being able to communicate between them. So we have our balloon script and our score manager. The score manager contained the variable for our score, and whenever our balloon popped, we were basically telling the score manager to increase the score by a certain amount. And then we also looked at Unity's UI system. We looked at quite just the basics of it with just having a little bit of text on top of our screen. But if you right click on canvas, go UI, you can see there is definitely a large number of different components. There's input fields, drop downs, sliders, buttons, etc. So do feel free to start experimenting with those and connecting those up as well, as they can be very useful in your games. So thanks for watching. Welcome back everyone. In this lesson, we are going to be creating our player game object. This is going to be basically the object or the collection of various different objects and children objects that is going to make up our player. Okay, and this is going to feature basically a root object for our player. As a child of that, we're going to have a 3D model and a camera. Okay, so we can look around. Now to start off with, I'm going to create a new empty game object here in the hierarchy, and I'm going to call this one player. Set the position to be 0, 0, 0, so it is nice and centered in our scene like so. And then what we're going to be doing is creating ourselves a little 3D model here. Now eventually we are going to be adding in a fully animated 3D night model here, but for now, let's just add in a basic capsule, okay? So I'm going to right click on player, go 3D object, and then capsule. This is going to create us a little 3D capsule right here. And what we need to do is actually change the size a bit. So first of all, I'm going to move it up so it is sitting on top of this grid plane here. So set that to a Y position of 1. And then what we're also going to be doing is reducing the width and the length of it a bit, just so it is a bit skinnier. So I'm going to set the scale here on the X to be 0.7 and 0.7 on the Z, just so we have a better idea of the dimensions of our player. Now, when it comes to our player as well, we're not going to be having the collider on our model, so we can go to our capsule here, right click on the capsule collider and go remove component. And instead, we're going to have a capsule component on our player. So I'll select our main player root object here, click add component and look for a capsule collider like so. Now, as you can see, the dimensions aren't really that good. So what I'm going to be doing is setting the center on the y-axis to be 1 and the height to be 2. We can also set the radius here to be 0.4, so it's a bit skinnier as well. And there we go. That is our capsule collider added to our main player object. And the reason why we're doing it this way is because with our model, you can see that the scale is a bit off. And if we do want to have our player object here have a 3D model that is a bit of on a bit of a different scale or a bit of a rotational offset, we can do that without having to modify or keep in mind the new forward direction or the new scale of our player. We can just have a set 111 scale on our main player and have the forward direction be the exact same. Okay, it just makes it a lot easier to work with if we have a consistent scale on our main player object. So you can see here we have the blue arrow pointing in the forward direction on our main player object. So that means our camera needs to be behind our player around here. And to do that, we can just select the main camera and drag that in as a child of the player. But this isn't going to work. We could have it like this, but when it comes to setting up the camera orbiting around the player, we need to set up a camera anchor, which is going to basically be the pivot point that we are going to be rotating around. We can do it without that by just feeding in a raw position just above the player's head, although that does require much more calculation. So having a camera anchor just on the player's head here and having the main camera as a child of that will make the process a lot easier. So I'm going to right click on player, go create empty, and I'm going to call this one our camera anchor. And I'm going to set this to a position of around, let's just say 1.9 or 1.8 on the Y here. So it is basically in the middle of the player's head right here. And then what we can do is drag in the main camera to the camera anchor, like so. Okay. Now with this main camera object, what we want to do then is change its position to be somewhere that is nice and close to the player and at a bit of an angle. So what I'm going to be doing is selecting the main camera. I'm going to go to our game view here and we're going to try and position it in an area that looks good. So first of all, X, we can keep that at 0. Y, I'm going to probably put this at around 0.5, so it is a bit higher than the camera anchor. The Z, we can bring that right back to around -3, and we might also want to rotate the camera down a bit, so I'm going to set the X rotation here to be 15, and we might want to increase the Y to 1. So you can see then we have a sort of above the shoulder view or above the head view of our player right now. But normally in action RPG games and third-person games, you have the camera at a bit of an offset from the player. You don't normally have the camera right behind the player's head. Instead, you'll probably have it a bit to the left or a bit to the right of the player. Well, in this case, we can just select our camera anchor right here and move it along the x-axis. So we can maybe set the x to be 0.5. So we do have it at that bit of an offset, and this is going to be where the player's sword is. They're going to be holding a sword in their right hand, so we sort of have a straight on view of what they're going to be attacking, okay? And this part is entirely up to you if you want the camera to be closer, further away, at a bit more of an angle, or at a bit more of an offset horizontally. That is entirely up to you, okay? But this is what I'm going to have right here, and at this point we are pretty much done with our player object. We have all of the game objects set up. Now all we need to do is add the rest of the components. So first of all, back in our scene view, I'm going to select our main player object right here, and we are going to be adding in a rigid body. Now a rigid body, this is going to apply physics to our player, because with our player we want to be able to move around, jump, be affected by gravity. So this is why we need a rigid body. In terms of modifying these values, all we are going to be doing is opening up the constraints tab right here and enabling freeze rotation on the X, Y, and Z axes. This will basically make it so if we hit a tree or hit a bump, or if the enemy runs into us, we are not going to just fall over and land on our sides, because at that point we won't really be able to do anything. So we're making it so that the player's rotation is not going to be affected by physics, only its position, which is generally what you want in a game. You don't really have a third-person action game where the player can fall over sideways and not really do anything. So we'll freeze the rotation there, and apart from that, that's all we're going to be doing on our rigid body here. Everything else is built in and pretty much done how we'd like. Now, along with this, we are also going to be needing two scripts for our player. We're going to be needing a player script, which is going to control most of the player's actions, and then a camera orbit script, which is going to manage the orbiting of the camera. So I'm going to go to our scripts folder here, and I'm going to create these two scripts right now. So we have our player script, and we have another C# script called camera orbit. Okay. And I'm just going to then attach these to our player game object right here. So drag that in like so, and drag that in like so to the inspector. So now on our player, we have our transform component, our capsule collider, our rigid body, our player script, and our camera orbit script. And that is everything set up and ready to go. Finally, in this lesson, what we're going to be doing is just setting up a little bit of a platform underneath our player so they can walk around. So I'm just going to right click in the hierarchy, go 3D object plane, and I'm going to increase the scale, set the position to 0, 0, 0 first, and just set the scale to 2 by 2 by 2 by 2. So there we go. We have a slightly large platform here. If we look in the game view, there we go. So in the next lesson, we are going to be working on our camera orbit script, okay? We're going to get the camera orbiting set up and ready to go, and from there, we can then implement player movement, jumping, attacking, and so on. So, thank you for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be working on our camera orbit script. We're going to be setting it up so that we can rotate our camera around our player. So to do this, we are going to open up our camera orbit script, which we created in the previous lesson and attached to our main player object right here. So let's just double click on camera orbit to open it up inside of Visual Studio. Okay, here we are. First of all, what we're going to be doing is deleting the start and update functions right here. And inside of this class, what we're going to do, first of all, is create our variables. So first of all, we need a variable to keep track of the look sensitivity. Basically, how far is our camera going to rotate based on distance that our mouse moved. So we'll go public float look sensitivity right here. And then what we also need is two variables to keep track of our min and max X look. So how far down can we look and how far up can we look? Because without this, that means we can just rotate our camera 360 degrees up and around, which we don't want. We want a maximum height that we can look up to and a maximum distance that we can look down to. So we're going to create two variables, one called public float min X look, because X is going to be the up and down rotational axis. And then we need a public float for the max X look. Okay, so we've got those two variables there. Now we also need a variable to keep track of our camera anchor object, because this script is attached to our player, not the camera anchor. So we need this camera anchor referenced as a transform variable. So here we'll go public transform cam anchor, like so. Okay, so we've got that. And finally, one last variable. Actually, we'll have two more variables. We're going to have a public boolean, and this is going to be true or false for invert X rotation. So basically, some people, they prefer to have it so that when you pull the mouse down, the camera rotates downwards, and if you push the mouse up, the camera rotates upwards. Whereas some other people prefer it that if you pull the mouse down, the camera looks up. And this is entirely up to preference. Some people prefer normal camera rotation. Some people prefer inverted camera rotation. Okay, so we're going to have the option there available, so we can enable or disable that. And then we also need a private float variable to keep track of our current X rotation, okay? Because our X rotation, we'll be needing to store this and check it every single frame for when we rotate it up and down. We need to make sure that this does not go above the max X look or below the min X look, okay? So we've got those variables there. Now the function that we are going to be working in will be the late update function. Now I'm sure you've all heard of the update function, which gets called every single frame. The late update function is basically the exact same, but this gets called at the end of the frame. So once all the other update functions have been called, just before it goes to the next frame, late update gets called. And the reason why we're doing this in late update is because if we do have this in update, there's a chance that this function could be called before our player's movement functions get called. And the reason why that's a problem is because we don't want to be rotating our camera before our players move, because depending on a number of different factors, it can result in jittery camera rotations, okay? So we're going to be doing our camera calculations at the very end, so it will be smooth. So here we're going to go void late update. You can see it is a function that can be automatically created, and it should be highlighted in blue here to show that it is a mono behavior function. So inside of late update here, what we're going to be doing is, first of all, we need to get our X and our Y mouse inputs. We need to know how far our mouse has moved each frame. So here we'll go float X equals input dot get axis, and to get the mouse axis, this is going to be mouse X, okay? Mouse X being left and right, so if our mouse is not moving, this value will be 0. If our mouse is moving left, it will be -1, and if our mouse is moving right, that will be +1. And that number will be higher if we're moving our mouse faster to the right, or that number will be even lower if we are moving our mouse faster towards the left, okay? So it does take into consideration the speed of the mouse as well, not just the direction that it's moving. And along with this, we also need to get our vertical mouse movement, so we'll go float Y equals input.getAxis mouse Y, which is the exact same, but for moving it up and down. Okay, so we got those two variables now. What we can do is rotate the player along the vertical axis, because when it comes to rotating the camera, we are only going to be rotating the camera up and down. When moving our mouse left and right, we're not going to be rotating the camera anchor. Instead, we are going to be rotating the entire player, because in many third-person games, you have it so that if you're looking left and right, the player rotates along with that, okay? So the player is always looking in the horizontal axis that you are rotating the camera in. And that just makes it a lot easier to play with, so we're going to be doing the exact same here. So to do this, we are going to go transform to access the main player transform component, dot Euler angles, which is basically the rotation, as a vector 3. And we are going to add to this. We're going to add to our current rotation by going plus equals, and the axis that we want to rotate along is going to be the y-axis. If we are rotating along the y-axis, that is the vertical axis, that means we are going to be looking left and right. We're going to be pivoting from the left to the right horizontally. Okay, so we'll go vector 3 dot up. And then multiply this by the X input, so how fast is our mouse moving, and then multiply that by the look sensitivity. Okay, so that is going to rotate our camera left and right, or in reality, rotate our player left and right. And as a matter of fact, let's save this script and go have a look and see if it works. So I'm going to go back to Unity here. I'm going to select our player object. I'm going to go down to where we have our camera orbit script, and we're going to fill in these variables. So first of all, look sensitivity, I'm just going to put this at 1 for now. Our min X look is the lowest we can look, and I'm just going to put this at probably something like negative, let's just say negative 60, and positive 60 for the max. The camera anchor, I'm just going to drag in our camera anchor transform like here, and invert X rotation, we'll leave that disabled for now. So we can save that, press play, and we should be able to move our mouse left and right. And as you can see, when I move my mouse left, our player is rotating left, and when I move it right, our player is rotating right. So it looks like we have that horizontal mouse movement or camera rotation implemented right now. Now it does look like our player isn't actually rotating, but it actually is, because if we look in the inspector here, you can see the player's Y rotation is moving as we rotate the camera around, while the camera anchor's Y rotation stays the same. Now for vertical rotation, we're going to be rotating along the camera anchor's X rotation here, and you can see if I modify that right now, you can see this is what it is going to look like once we implement that. Okay, so I can unpress play here, and we can then return to our script where we are going to be implementing the vertical rotation. And this is a bit more complex compared to what we've done right here. Right now it's just one line of code, whereas with vertical rotation, we do have to keep in mind that we have the minimum X look and the maximum X look. So we have to take into consideration how far up and how far down we can look before affecting our camera's rotation. So we'll be continuing on with this script in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be continuing on with our camera orbit script in rotating our camera left, right, and up and down. So in the previous lesson, we set up horizontal camera rotation. Here inside of the late update function, we are getting our mouse's X and Y inputs. So if we're moving it left and right or up and down, we're getting basically the value or the direction and speed at which we are doing that. And here we are applying that to our player's horizontal rotation so we can look left and right. Now what we need to do is have the ability to look up and down. And to do that, what we need to do first of all is instead of modifying our camera's rotation directly, we are going to modify this current X rotation variable, which we created. So here we are going to go cur x rot plus equals Y multiplied by look sensitivity. Okay, so we're adding basically however far we moved our mouse multiplied by the look sensitivity to this current X rotation value. And now what we need to do then is clamp this. And clamp basically means we have a value and we basically force it to be in between a minimum and a maximum value. The minimum being the min X look and the maximum being the max X look. Okay, so we are sort of restricted in how far up and how far down we can look. And to do that, we can go cur x rot equals mathf.clamp. And with this function, we give it three values. The value we want to clamp, the minimum, and the maximum. So the value is going to be the current X rot, the minimum is going to be the min X look, and the maximum is going to be max X look, okay? And there we go. We've clamped this value now, so it can't go above a certain value or below a certain value. Now what we need to do is apply this to our camera's rotation. So what we're going to do first of all is create a local variable which is going to store the current camera's rotation, so then we can apply this new value to it and then assign that back to the camera. Okay, so what I'm going to do here is go vector3 to create a new variable called clamped angle, and this is just going to be equal to our current cam anchor dot Euler angles. Okay, so we're getting the current camera's rotation and assigning that to this clamped angle variable here. Now what we're going to do is just go clamped angle, not camera anchor just yet, clamped angle dot x equals cur x rot, like so. Okay, so we're assigning the x rotation, and then finally we can just go cam anchor dot Euler angles equals clamped angle, like so. Okay, and that is how we do the up and down rotation. Okay, so quick overview. Here we are getting our inputs from our X and our Y on our mouse. Here we are rotating the player left and right. Here we are adding on our mouse's up and down value to our current X rotation variable. Here we are clamping that variable to make sure it is in between the minimum and maximum X rotation basically barriers. Here we are creating a temporary variable and assigning that to our camera's current rotation. We are then assigning the X rotation or the X axis to be our current X rot, and then here we are applying that new variable to our camera's rotation. Okay, so we can save that. We can then return to the Unity editor right here, and let's press play and see if it works. So we can move left and right like before, and now we can look up and down. If I drag the mouse down, the camera looks up, and if I drag the mouse up, the camera looks down. Okay, so right now it is actually in inverted camera angle right now. So what we should actually do then is implement the ability to enable or disable inverted camera. So back inside of our script right here, we have this invert X rotation variable. Now let's implement that. So here is where we're going to implement it, where we go current X rot plus equals Y times look sensitivity. Okay, now we are going to instead put this on a new line here and put this inside of an if statement. So here we are going to go if invert X rotation, then this is what's going to happen. Otherwise, we'll go else, and then that's going to be current X rot minus equals Y multiplied by look sensitivity, okay? So if we are inverting the X rotation, then we're going to be adding this. Otherwise, we're going to be subtracting this. Now, you might be used to if statements with the curly brackets, but in C#, it's a pretty cool thing. If we are only having one line inside of our if statement, we don't actually have to put any curly brackets. So it does save up some space in terms of lines of code with the curly brackets. But do keep in mind that this is only possible if you have only one line of code under your if statement here, okay? So there we go. We can save that. We can return to the Unity editor now and test it out. So if I select the player, you'll see that invert X rotation is off. So we should be able to pull our mouse down to look down, pull it up to look up. Yet if I enable that, we can then pull our mouse down to look up and pull it up to look down. So there we go. We have invert X rotation enabled now. You can, of course, go through, modify the look sensitivity. We can maybe increase it to 1.5 if we wish. And something else that we might want to do that may be bothering you is disabling the mouse cursor, because right now we see our mouse cursor on screen, and eventually once we implement the ability to attack enemies by left clicking, we don't want to accidentally have our mouse over maybe on the X here and accidentally left click and close the program. We want to make it so our mouse is constrained to the game window here and invisible. And we can easily do that with one line of code inside of Unity. So let's open up our C# script here, and I'm going to go and create the start function. So right at the start of the game, this is what we are going to do. And inside of here, we are going to go cursor.lockState equals cursor lock mode dot, and you'll see there are a number of different things here. You have confined, which basically confines it to the game window. Locked, which basically locks it to the center of the game window and also makes it invisible. And none, which just makes it behave as it is normally. Pretty much what we got right now. So I'm going to set this cursor to be a cursor lock mode of locked. Okay, we can save that, return to the Unity editor, and when we press play, you'll see that our mouse disappears. And we can look left and right as much as we want, so I can spin the camera continuously along the right hand side here, and the mouse is not moving off the screen or getting stuck, which is very nice. Okay, so we've got our camera look set up and ready to go. We can look up, we can look down, we can move our mouse left and right to rotate around. Now what we need to do is implement the ability for our player to move around and have the player move relative to where we are looking with our camera. So if we're looking over here, if we press W, we want to move in this direction. If we look over here and we press W, we want to move in this direction, okay? And all the other controls, so left, right, and backwards, should also be relative to the direction that we are looking at. Now, if you're on the screen, you may be wondering, okay, how do I get out of play mode? Because you can't click on any of the buttons here. Well, what you can do is click the escape key, and this will re-enable your mouse cursor, and if you click back on the game window, it will toggle it back like here. Another way to stop playing the game is by holding down Control and pressing the P key, or Command P if you're on a Mac, and this will basically toggle play mode. So, thank you for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be implementing player movement into our game. In the previous lesson we set up our camera orbit so we can now look around with our camera. So let's start implementing the ability to move in the direction relative to where we are facing. So I'm going to open up our player script, which we have created down here. And inside of our player script here, I'm going to start off by just deleting the start and update function since we don't need those just yet. And we will begin by creating some variables. So for movement, we need a few things. First of all, we need to have a public float variable for our move speed. So how many meters per second are we going to be moving at? And then we also need our rigid body component, which is going to be basically a variable that is going to reference our rigid body component, as the way we're going to be moving around is by setting our physics velocity. Okay, so here I'm going to go public rigid body, rigid body like so, and I'm just going to call this one ridge. Okay, so we've got our two variables there. Now what we're going to do is create a function called move. So we'll go void move like so. And this function is going to be called every frame. Now, in order to have this function actually be called, we need to call it inside of the update function, which gets called every frame. So up here, I'm going to create the update function. And inside of the update function, we are just going to call our move function every frame. Now, the reason why we aren't just having our move code inside of the update function, well, we could do that, but the reason why is because we're going to have a number of different systems as well, and this just makes it a lot easier to understand when looking at it for the first time. We can see, okay, we are calling move, and all of our move code is contained inside of one function. It just makes it easier once you have a bunch of other systems as well stacked on top of this, just in order to understand it, okay? Now, in order to move around, we need to get the input from the player's keyboard. So we need to be able to get the left and right axes and the up and down axis. Similar to how we done it with the mouse, where we were able to move our mouse left and right to get the X and up and down to get the Y. We can get our keyboard horizontal and vertical axis. The horizontal being the A and D keys, A being -1, D being +1, and nothing being 0. Alternatively, we could also use the arrow keys, so left and right arrow keys will move horizontally as well. And for vertical, this is the up and down arrow keys, or the W and S keys. So here we're going to create a float X called, or a float variable called X, and this is going to be equal to input.getAxis, and this is going to be the horizontal axis like so. It's going to be between -1 and 1. -1 for if we are pressing the left button, and +1 for if we are pressing the right button, and 0 if we are pressing nothing. Then we need the exact same this time for Z, which is going to be forwards and backwards, and this is going to be the input.getAxis vertical. Okay, we're getting the vertical axis here. And there we go. That's how we get our movement axes from our keyboard and storing them in as variables. Now what we need to do is assign this to our rigid body velocity. So we could just go, for example, vector3, create a new vector3 here called dir for direction. And this could then be equal to something such as new vector3. We give it the X, we set 0 for the Y, and Z for the Z here. Multiply that by our move speed, and there we go. Okay, and then finally we just need to go rig.velocity equals dir. Okay, so we're setting our velocity to equal this new directional velocity here. Now, this isn't what we are going to be doing in the final product, but I'll just show you that this is a rough example of how we can get something like this set up and moving. So we can save the script, return to Unity, we'll select our player and give ourselves a move speed of around, let's just say 3, drag in the rigid body component and press play, okay? So we're here, you'll see if we move right, and then left, back and forwards, we're pretty much moving in the way that we should. We could probably even boost up our move speed to something such as 5 here. There we go, we can move left, we can move right, we can move backwards, and we can move forwards. But look what happens if I move to the left here, and then, or if I rotate the camera to the left and then start moving. You'll see that our controls are not relative to the direction we are looking at. If I press W to go forward, we're moving to the right. And that is the problem we have to fix right now. So I'll go Control P to unpress play. I'm going to set the move speed to 5 right here. Now back inside of the script, what we need to do is make it so that whenever we are moving forward not based on the world direction, but based on our local direction, based on the direction that our player is facing, okay? And in order to do that, we need to do this tiny little algorithm here, which is just going to get our transforms forward and right directions and multiply those by our inputs here. Okay, so instead of direction equaling this here, we're going to delete that. Okay, so it's going to be vector3 dir equals transform.right, which is our right direction, multiplied by x, plus transform.forward multiplied by our Z, which is our forward input, our W or S or up and down arrow key. And there we go. We are now getting a relative direction based on where our player is facing when we are pressing our inputs, which is great. Now finally, we just have to multiply direction by the move speed, so multiply that by move speed, and then we need to set the Y direction to be whatever our current y velocity is, because if we were to fall off an edge, we don't just want to hover midair, we want to continue falling down based on gravity. So I'm just going to go dir.y equals ridge.velocity.y. And there we go. That's what we need to do in order to get this relative directional movement. So we can go back to the Unity here, save that, press play, and as again, you can see I can move forward, back, left, and right. But if I face the side here and do the same, I'm also moving forward, back, left, and right relative to wherever we are moving. You can see if I hold down W and rotate the camera around, we are now moving in a circle, which is great. This is exactly the sort of behavior that we want from our player here, our player movement. Okay, so we've got all this set up. Now, one more thing to finish this off is the lighting. As you can see here, although this is just a test environment where we are just testing out the base mechanics with no amazing graphics or anything, you'll see that the lighting is very harsh. Over here, it's not even that bright, yet in the shadows, it is pitch black. And the reason why is because currently, auto-generate lighting is off. In Unity, we are using real-time lighting, which basically means each frame it is calculating where the shadow should be and the luminosity of everything. And that's not really being done correctly, so we need to go down to the bottom right corner of the screen and select this auto-generate lighting off button. This is going to open up our lighting screen right here, or lighting window, and we just want to enable auto-generate right there. And then we can just close the window, and there you go. You can see that our scene is now correctly lit. It's got the nice shadows, no more harshness there, and the ground is white, which is the color that it should be. And to make our player contrast from the ground a bit more, because right now they do blend in a bit, I'm going to go ahead, go to the assets here, and create a new folder called materials. And we can, of course, delete this in the future once we actually get our proper environment. And inside of materials here, I'm going to create two materials, one for our player and a material for our ground. Okay, so these are both going to have different colors. So in our scene view, I can drag on the ground, drag the player onto our player, and then we can set them. So for the player, I'm going to give them a red color, and for the ground, I'm going to give that a green color, something like that. Okay, and there we go. We can press play and test this out in our game. And as you can see, we can of course move around, but now we need to jump. And we are going to be working on jumping around with our player in the next lesson. So I'll see you all then. Welcome back everyone. In this lesson, we are going to be implementing the ability for our player to jump, because right now we can move around, we can look around, but we don't have jumping enabled. So let's go over to our player script right here. And inside of this script, we are going to go up to the update function where we are going to be detecting inputs from our keyboard to check to see if we are jumping. So under where we are calling the move function here, I'm going to go if input.get key down, which is true on the frame that the specified key has been pressed down, and this key is going to be keycode.space. Okay, so when we press down the space bar, what we are going to do is call the jump function. So I'm just going to go jump right here, and let's go ahead and create that jump function just under move here. So go void jump, like so. Now, when it comes to jumping, we need to know if we are standing on the ground, because we don't want to be able to jump if we are mid-air. So the way we're going to be doing this is with ground detection. And inside of Unity, normally the best method of ground detection is by using a raycast. And a raycast is pretty much a line that you give a position to and a direction, and it shoots off like a laser. And if it hits something, it will tell us what it hit, how far away it was, and all this other information. Well, pretty much what we want to do is shoot a laser from the bottom of the player's feet downwards around 10 centimeters, okay? And if it is hitting something, then that must mean it is hitting a solid surface, meaning that the player is standing on the ground. Now, if that raycast is not hitting anything, then that must mean the player is mid-air, meaning we cannot jump. So I'm going to create another function underneath jump here, which is going to return a Boolean variable, and this is going to be can jump. Okay, and inside can jump here, what we're going to be doing is first of all creating a array called ray, and this is going to be equal to new ray. And with ray here, we need to give it two values. we need to give it an origin and a direction. The origin is going to be basically where the player's feet is, and the way we've set up our player is that the pivot point or the origin for our player is pretty much on their feet, okay, in the center of their feet. So we can just give ourselves the transform.position for the origin, and direction is going to be vector3.down, okay? So we are shooting a laser from our feet down towards the ground. Then we also need to create something known as a raycast hit, and a raycast hit is an object that contains the information about what it has hit, about what this ray has hit into along its journey. So here we'll go raycast hit, and we'll call this one hit. And this doesn't have to equal anything right now. In fact, we can then just go if physics.raycast, and this is how we can actually emit this raycast. We need to give it the ray, and then we can go out hit to basically output the hit information to this variable. And then we can give it a distance to travel at. Now, we only want it to travel a short distance, so we can just go 0.1 f for around 10 centimeters. And there we go. We have cast a raycast. And then inside of this if statement, we want to see if this has hit anything. If this has hit something, then we are going to return true. Otherwise, we are going to return false. So in here, we're just going to go return hit.collider for the collider object that we hit doesn't equal null. So pretty much hit collider doesn't equal null is going to give us a true or false. This is a condition we are checking to see if what we have hit does exist. So does the object we hit exist? If it does exist, it's going to be true, and if it doesn't, it's going to be false. So can jump is going to return true for if we can jump, and false for if we cannot. Now you'll see there is a red squiggly line, and that is because if this if statement doesn't run, it's not returning anything. So under here, we can just go return false, okay? But most of the time, this is not going to be called. So now what we can do is over inside of our jump function, we can check to see if we can jump. So we can go if can jump. So we can call the if can jump function right there. Then what we are going to do is add force upwards to our player. And the way we can do that is through our rigid body. And as a matter of fact, let's go up to the top now and create another variable which is going to store our jump force. So we can go public float jump force. And this is going to be the force applied upwards to our player when they are jumping. So if the player can jump, if they're standing on the ground, what we want to do is just go ridge.add force. So basically add force can push an object in a certain direction. The direction and force we want to apply is going to be vector3.up. So we want to move upwards. And then we want to multiply that by the jump force. So we have this varying jump force being applied to the up direction. And then we want to go comma and then force mode dot. And you'll see there are 4 different force modes. Now in Unity, by default, it is acceleration, which basically means that you could think of acceleration as pushing a car or accelerating in a car. Once this car starts basically moving, it gradually increases momentum over time. Whereas if you were hitting a golf club with a golf ball, that golf ball is going to instantaneously move at its max speed, okay? So you can think of force mode in 2 different ways pretty much. You have gradual speed increase and instantaneous velocity. Now for us, we want to jump, so we want to be snappy, we want the player to instantly start moving upwards. And to do that, we're going to go force mode dot impulse, which basically means instantaneous movement. Add a semicolon at the end of that to finish off the statement, save it, and then we can return to the Unity editor. Now we can select our player, and we are just going to give them a jump force. I reckon we could give them a jump force of around 5. That might be alright. We can, of course, change this later on. Press play, and let's test it out. So we can move around, we can look around. Let's press space, and there we go. We are jumping in the air. You can see our shadow there as we jump, and if I try and spam the spacebar, you can see I'm not jumping. I'm only jumping if we are standing on the ground and not mid-air, which is exactly how we want it. Okay, so that is our jumping mechanic set up and ready to go. Okay, so in the next lesson, what we're going to be doing is setting up our enemy, and the enemy is going to be an object which can chase after the player, and when it gets to a certain distance away from us, they will begin to attack us. And later on, we'll also then implement the ability for us to attack the enemy back. Okay, so thank you for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at setting up our main menu. So this is going to be in a brand new scene. So let's go down to our scenes folder right here, and I'm going to right click and go create scene, and I'm just going to call this one menu. Okay. We then want to double click on this to open it up. Yes, we'll save the scene we're currently in, and here we are in a brand new scene. Now, the first thing we're going to do is make it so that the background, if we go over to our game view here, isn't the skybox. Okay, we're going to make it a nice flat color. So let's select our main camera game object. And in the inspector, let's change the clear flags from skybox to solid color. This basically means that if there is no object in the way, it's just going to render a background color. And we can, of course, change that by changing the background color property right here. And I'm just going to make this a nice green, something like this, perhaps, okay? And then what we can do is we can go ahead and create our canvas, which is going to hold our UI elements. So I'm going to right-click and go UI canvas. That's going to create a new canvas and an event system. And then on our canvas, we are going to have 3 different UI elements. We're going to have some text for basically the name of the game, and 2 buttons. One that is for playing the game, and one for that, and one we press when we want to quit. Okay. So I'm going to right click on canvas. I'm going to go UI text mesh pro. Let's call this one title text. We can hop over into our scene view. And if you're not in this view that I'm right now, you just want to click on the 2D button at the top right corner of the scene view, and then select the text or select your canvas and press F to focus in on it. Okay. So for our title, I'm going to position it just above the center like so, and I'm going to make it bold. Font size, we can keep it at about 36, and let's just center the alignment as well. And I'm going to call this one My 3D Game. There we go. Okay, now next up we need 2 buttons, one to play the game and one to quit the game. Now for buttons, we can right click on canvas, go down to UI, and you'll see down here we have a long list of different elements we can have, sliders, scroll bars, but you'll see there is a button dash text mesh pro. Let's click on that, and I'm going to call this one our play button. Okay, so now for this button, I'm going to increase it in size a bit, like so. And then I am going to open it up because, as you can see, there's a child object, which is the text element. And I'm going to rename, I'm going to change the text to display play. Okay, just like that. So if we look in our game view, that's what it's going to look like. And then for the second button, we can just copy and paste the play button or Control D to duplicate it. Move it down a tiny bit. I'm going to rename this to our quit button. And then change its text to say quit, okay? And there we go. So when we press play, as you can see, if I press play, I'm actually able to click on these buttons. You can see there's a little color change, but they don't do anything. So how do we make it so that when we press play, it will launch us into our first level, and quit will basically quit the game? Well, for that, we are going to be creating a script. So let's go to our scripts folder, and we're going to create a new C# script called menu, okay? And this menu script, I'm going to go ahead and attach this to our canvas, since I reckon that's probably going to be the best place to have it for now. Attach to the canvas, and then let's open it up. Now, inside of the menu script, we're not going to be needing start or update, so we can delete those 2 like so. And instead, we are going to be adding in using Unity Engine.scene management, because we do want to be able to switch between scenes. Now, the way that the buttons work is that when you press a button, you can set it up so that it can actually call a function on a given component. So what we're going to do on this menu script, which is a component of Canvas, is we are going to create a function for pressing the play button and a function for pressing the quit button. So I'm going to create a public void, and I'm going to call this one on play button. Now, it is important to note that this function has to be public because we are going to be accessing it from outside of this class. And when we press the play button, what we want to do is load into the first level. So I'm going to go scene manager load scene, and there's two ways you can do this. You can, of course, enter in the name of your level 1, okay? But later on, you might go ahead and change the name of the level. You might make it level 1.1 or whatever. So instead, I'm just going to use the build index of 1, okay? Now, the build index of 1 is not the first scene, but the second one, okay? 0, build index 0 is going to be our menu scene, and then build index 1 is going to be our level 1. So we can just enter in the build index like so. And then we have the quit button. So I'm going to create a public void on quit button function right here. Now, what this is going to do is it's just going to quit the application, okay? So if we have our game window up and we press quit, it's going to close down the game. Now, Unity has this already set up for us, so all we need to do is go application.quit, okay? Just like that. And that is going to close down our game pretty easily. So yeah, on play button and on quit button, these are the two functions we have created. Now let's go over and connect those to the buttons. So, back inside of the editor right here, what I'm going to do is I'm going to select the play button right here, and I'm going to go down to the inspector. Now, in the inspector, you see that we have an image component, which basically renders the button background image, and then we have a button component, and this is basically in charge of detecting when we're clicking on it and changing the tint for when we're highlighting, when we're pressing, etc. And you'll also see something down here which says on click, and it says list is empty. Now, this is what is known as an event listener. We're not going to really go into what an event is, but basically this is a list that we can attach functions to so that when we press the button, those functions are executed. So what I'm going to do is click on the little plus down here at the bottom right to add a new item to the list, and I'm going to drag in the canvas to the object field here, and then where it says no function, I'm going to click on that, I'm going to hover over our menu, and then I'm going to select the on play button function right here. So now, when we click the play button, this on click event is going to basically look at its list of functions and it's going to call those. So before we press play and test this out, let's first of all go to File, Build Settings, and add the menu here. Now, to quickly add the scene you're currently in, we can just go Add Open Scenes. That's going to add the menu to the list, but we want menu to be the first scene in the list, so I'm just going to click and drag it up here, okay? That is because menu is now build index 0, level 1 is 1, level 2 is 2. We can then close out of this, press play, and then when we have launched into our game, let's press the play button and see what happens. And you'll see it takes us over to level 1, and then we can of course play through this game here. So yeah, that is the play button working. Now, as a bit of a challenge, I want you to go ahead and set up the quit button right here, okay? I want you to connect this up to our on quit button function, which of course is our menu script that is a component of Canvas. So it works in pretty much the exact same way as we've done with the play button, but you're of course choosing a different function. So have a go at that, and I'll be right back to see how you're done. Alright, so I hope you had to go at that challenge. Now let's look at how we can actually complete it. So what we need to do is first of all select our quit button here, and we are going to go to the inspector. We're going to go down to our button component right here, and we have the on click event. So I'm going to add a new item to the list here by clicking on the plus. I'm going to drag in the canvas object because that's where our menu script is attached to. I'm then going to click on no function, go to our menu component, and then click on the on quit button function. So now the on quit button function is connected to the quit button. So if I were to press play, there is one thing that you may notice, and that is if we click on the quit button, nothing happens. And that is because application.quit, that line of code we wrote in order to actually quit the game, that only really works if it is a built and compiled project, okay? That doesn't really work here in the editor because otherwise, you'd probably close the editor down. That only works if it is actually a built game. So you can, of course, then build your game and test it out, and that should work. So yeah, that is how we can build our menu scene here inside of Unity. Now, in the next lesson, we are going to be looking at just setting up another level so that we can actually get some level progression going, and then connecting the end flags, and then connecting it back to the menu so we can have a full game set up and ready to go. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, and welcome back. In this lesson, we are going to be working on a day and night cycle for our game. Now, the thing about this day and night cycle is that it can just be drag and dropped into any project that you have. Okay, it's not specific for this game that we're creating right here. You can just copy over the script as well as modifying a few things here in the inspector in order to have this working in pretty much any game you want. All right, so first things first is that we need to set up a few things here in the hierarchy. The first thing is our directional light. Okay, if we select our directional light here, this is what we are going to be using as our sun. Now, I'm going to go ahead and rename this to sun, like so. And as well as a sun, we also need a moon. We're not going to be using the same directional light. Instead, we're going to be copying this. So I'm going to go Control D to duplicate the sun like so. And I'm going to rename it to moon. Now, I'm also going to go ahead and disable the existing sun here, just so that we can work on the moon. Now, with moonlight, generally at nighttime, the lighting is, of course, very dark, but there's also a bit of a blue tint, all right? And this can be an artistic style, but we're going to create our moonlight a bluish color. So I'm going to make it a bluish color like so. As you can see, it already looks a bit darker, even though we haven't changed anything apart from the color. And along with this, I'm also going to bring down our shadow strength to be 0.5, just so the shadows are a bit weaker during the night. Now that we have our moon, I'm going to disable that and enable our sun by default here. Now, if you don't have your lighting panel open, you can go over to Window, you can go to Rendering, and then Lighting, and that's going to open up the lighting window right here. And we want to go over to the Environment tab. Now, in the Environment tab, make sure that your sun source is set to that sunlight that we just renamed before, okay? It's very important, as that is what the skybox, if we look around, we have our sun right here in the sky. This is what is going to be moving up and down and modifying the colors of the skybox based on the sun's rotation. So in the inspector, if we select our sun right here and we modify, let's just say the X value, you'll see that as I rotate the sun, you can see the direction with the blue arrow right here. You can see that the skybox is changing, and when it gets to nighttime, so when the sun's facing upwards, it turns dark. Now, this seems to be all right now, but the problem with this is there are still a bunch of things that we need to change, such as the intensity of the skybox, the reflection intensity, as well as also having our moon move as well. Now, this day-night cycle is going to be very customizable, and there will be many different options that we can do to basically tweak it to how you'd like. So, what we need to do now is I'm going to go and create ourselves a brand new script right here. So I'm going to create a C# script called day-night cycle, and I'm going to create ourselves a new empty game object. I'm going to call this game object right here day-night cycle. Let's just set the position to 0, 0, 0 to be consistent here. I'm going to drag that script on like so and open it up inside of Visual Studio. We're first going to create ourselves a public float variable for the time. Now, this is going to be a number ranging from 0 to 1. 0 being 12 in the morning and 1 being basically 11:59 at night. And 0.5 will be midday. So we can restrict this to a specific range by adding in the range attribute right here. We need to give it a minimum and a maximum, 0.0 for the minimum and 1.0 for the maximum, okay? And in the inspector, there'll be a little slider that we can then slide back and forth to test this out. Next, we need to know, okay, how long is a full day going to be in terms of seconds? So we'll create a full day length variable right there. We also need to know the start time. At what time, when we press play on the game, is the day going to be? Is it going to be at midnight? Is it going to be midday? This is where we'll define that. So public float, start time, and by default, we'll set that to 0.4f. So that will be sometime in the morning, late morning. Now, along with this, we also need to know our time rate, and this variable is just going to be there. We're going to be assigning this at the start of the game, and this is just going to be, okay, every frame, how much do we increment the time forward? So this is going to be a private float time rate, Now, when it comes to rotating the sun and the moon around, we are going to rotate it based on the rotation when it is noon, okay? So here I'm going to create a public vector3 and call that one noon. We'll be assigning this in the inspector, and this is just going to be the rotation of the sun when it is at noon. So basically when the sun is facing directly above the player. All right. Now, along with this, we also need settings specifically for our sun and for our moon. So I'm going to go down here. I'm going to create a new header attribute, which is just going to give us a bold header in the inspector. So this sort of stands out. I'm going to call it sun. And inside of sun here, we need 3 variables. First of all, we need the sun light component, so we can modify the brightness, modify the rotation and all that. Next, we are going to create a gradient variable. So public gradient, and I'm going to call this one sun color. Now, a gradient in Unity, it has a range between 0 and 1. And if we basically evaluate or if we sample a number, we can basically get a specific color. And I'll show you what that means in just a second. We also want to do the same thing for the sun intensity. So I'm going to create a public animation curve, and I'm going to call this one sun intensity. Okay. Now, this may not make a lot of sense. Why we're using animations for defining sun intensity? Well, animation curves are a very powerful thing when creating games in Unity, and they aren't just for animations. We can use it to basically sample a specific time to get a value. So let's save this right now, go back into the inspector, and have a look at what I mean. Okay, so here in our day-night cycle script, once it loads up fully, what we're going to do is set the time. We're not going to modify the time actually. Let's set the full day length to something such as, I will set to 30 for now, just so the days go pretty fast. We can drag in our sun here. Now for noon, this is going to be 90 on the X, 0 on the Y, and 0 on the Z. So if we select our sun here and enter in those specific values, there you go. The sun's looking directly down and it is noon. Okay, I'm just going to set that back to the default there. So on our day-night cycle now, we have our sun color and sun intensity. So what do these mean? Well, sun color, if we select that, it's going to open up the gradient editor. Now, you may have seen this before in Unity. Basically, at the bottom here, we can select a node, change this color to something, and select the other node here, and change that color to something else, and we now have a gradient transitioning between these two colors. We can also create more nodes by clicking and assigning those a different color like that. Now, the way we're going to be using it is, since our time is based on a 0 to 1 scale, 0 being midnight and 1 being just before midnight, and 0.5 being midday, what we can do is go, okay, at midday, so it would be around 50% the way through this gradient, what color do we want to make the sun? And then let's just say, okay, it's early morning, so we're over here on the left-hand side, what color do we want to make the sun? And we can sample a specific color at a specific time along the gradient. So in the morning, we might want a more orange sun, or making it a bit more bright during the day. And that is also what we're going to do with the sun intensity. So with the sun intensity, this is an animation curve. And at the bottom here, we can select one such as this here. And you see it creates a curve. And it ranges, if we look at the bottom, along the x-axis from 0.0 to 1.0. And just like with the gradient, we are going to be basing the sun's intensity off the sample that we get from here. So let's just say it's midday, so 0.5. This means that the sun intensity is going to be around 0.75, okay, based on this animation curve. So we can make the sun intensity be very low during the morning and very high during midday. So we can do something like this, okay? During the morning, it's low, but as it goes to more towards midday, the sun intensity gets brighter, and then it goes back down during night. And this is how we can accurately define various things such as the color and the intensity. So in the next lesson, we're going to continue on with this and set up our sun settings, set up our moon settings, and our other lighting settings. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be continuing on with our day-night cycle. So between now and the last lesson, I've actually gone ahead and set up our sun color. So it is this nice orange color during the morning and evening, and it transitions to this much brighter color during midday. okay? And for our sun intensity, I have it so it is pretty much at 0 during midnight, and as the day goes on, it gets brighter and brighter, and then it gets darker and darker as it becomes nighttime again. So let's open up our script here and continue on with setting up our variables specifically for the moon. Okay, we want to do pretty much the exact same thing here that we done with our sun, but do it for the moon. So I'm going to enter in a moon header right here, and then we can create our variables. So just like before, we have a public light for the moon, we have a public gradient for the moon color, and we have a public animation curve for the moon intensity. Okay. Now, along with this, we also want to be able to modify some more specific settings, okay? And that is going to include the lighting intensity and the reflections intensity. So I'm going to save this script, return to Unity, and I'll show you what those two things are. So if we go over to our lighting window here, and under Environment tab, you'll see we have Intensity Multiplier right here. Now, with the intensity multiplier, we can increase that and you'll see the scene gets brighter, okay? So it is taking on more light from the skybox, and if we decrease that, it is taking on less, okay? So at nighttime, we're gonna have this very low, and during the day, we're gonna probably have it at about 1. Now, for the reflections intensity, this is very noticeable at nighttime because right now, if we were to make it night, you'll still see a lot of reflections from the blue skybox. So what we want to do is we'll be decreasing that intensity multiplier down so there are less reflections from our skybox, okay? So let's hop back into the script now and implement those two things. So I'm going to create a header here, and I'm going to call this one Other Settings, or Other Lighting actually. And then we can create the two animation curves. So public animation curve, and this is going to be lighting intensity multiplier. And then we want a public animation curve for the reflections intensity multiplier. And there we go. Okay, so we've got all of our variables now. Now, what do we have to actually do at the start of the game? Well, here's what we're going to do. Inside of the void start function, we are going to first of all set the time rate. So the time rate is going to be equal to 1.0f divided by the full day length. Okay, so time rate is basically how much time do we add to our time every second. So let's just say our full day length here is 10 seconds long, okay? So 10 seconds for a full day, so that means in order to get from 0 to 1, we would have to add 0.1 every second. So time rate would then be 0.1. Now, along with time rate, we also need to set the time of the day at the start, so time is going to be equal to start time, and that is it for the start function. Now, the update function is where we are going to be updating all of the other things, okay? Updating the positions, updating the colors, updating the intensity. So let's go ahead and do that now. I'm going to create the update function here, which gets called every frame. And inside of the update function, we first of all want to increment time. So we'll go increment time right here. And to do that, we're going to go time plus equals time rate multiplied by time dot delta time. So we are multiplying it in a way so that we are adding time rate every second. And we then want to check, okay, if time is greater than or equal to 1, then we want to set that back down to 0. So it basically loops around. So if time is greater than or equal to 1, then we'll go time equals 0. So it's the start of a new day. Next, we want to basically be rotating our sun and our moon. So here we're going to go light rotation. And to do this, we are going to go sun.transform.Euler angles equals. Now, the little formula that I'm going to write here is just going to make it so that as our sun rotates around, the moon is going to be rotating around basically in the opposite direction. So when our sun is at the top of our world, the moon is going to be at the bottom, okay? And as those two rotate around, they are basically going to be in sync. So the sun's Euler angles, or its rotation, is going to be, in brackets here, time minus 0.25 f multiplied by noon, so basically multiplied by the noon rotation, multiplied by 4. Okay, This just adds a little offset to it so that at midday, our sun is basically going to be shooting directly down, and during the night, it is going to be rotating upwards. So we then want to do the same for the moon. So moon.transform.eulerangles equals time minus 0.75. So we have a bigger offset on that, multiplied by noon, multiplied by 4. So that is going to be rotating our lights around. The next step is to be setting our sun and moon intensity. So here we'll go light intensity. And so how do we actually get the value from an animation curve? Because animation curve isn't a variable that we can just set as a number or get as a number. We have to call the evaluate function. So here we're going to go sun.intensity equals sun intensity dot evaluate. And evaluate, we need to give it a time. Now, time is basically the x-axis. So if you remember, the x-axis on the animation curve is the one right at the bottom of the screen, and ours ranges from 0 to 1. We can evaluate a specific time, and that is going to return us the value of the curve at that specific time. So in here, we're going to just enter in time. And the same for the moon. We'll go moon.intensity equals moon intensity dot evaluate time. Now, before we continue, let's go back to our script. Let's go back to the inspector and fill in the rest of our variables and test this out to see if it even works. So back inside of our inspector here, I'm going to select the day-night cycle, and I'm going to drag in our moon object right here. But we also need to set a moon color. So I've already got one right here, a little gradient. For the moon color, it doesn't really matter, as the only time we're going to be seeing the moon is when it is very dark. So I'm just going to keep the moon at this blue light right here. And for the moon intensity, I am going to make it look like this, okay? And to add new key points, you can just double click to create a new key point like so. And this is what our moonlight is going to look like. So at midnight, it is going to be at 0.5 intensity, because we don't want the moon to be too bright. It is nighttime after all, and the moon isn't going to be as bright as the sun. So 0.5 at midnight. By the time it gets around a third the way through the day, so this will be around mid-morning, it's going to be right down to 0. Okay, so the moon is no longer visible. And then towards the end of the day, once it's starting to get dark, it will slowly rise up again back to 0.5. So that is going to be our moon intensity. Now let's press play and test it out. Make sure that you have set the full day length to something. I'm actually going to change this down a bit lower, maybe 15 seconds. Let's press play and see how it goes. So we are now, if you look at the right hand side, the time is ticking up. It's getting nighttime now, sunset, night, and the sun should be then coming back up around here any second now as it becomes day again. And there we go, the sun's rising, it's rising, and you can see the light of the sun is updating the shadows as it moves around. And as it gets nighttime, we now have the moon shadow also appearing, which we can't really see because right now we aren't actually enabling or disabling the moon, which is something that we do need to do. So in the next lesson, we are going to be continuing on with our day-night cycle here, setting up the ability for the moon and sun to be enabled or disabled based on the time of day, as well as setting up our other lighting settings here so we can have a much more fleshed out day-night cycle. Thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be continuing on with our day-night cycle right here. In the previous lesson, we set up our sun and our moon so they are now rotating around in our world. So back inside of the script, what we're going to be doing now is setting it up so that the colors are also going to be changing as the days go on. Okay, so here we are going to be setting up the change colors. And to do this, it's going to be very similar to how we set up the intensities here. So we're going to go sun dot color equals, and we are going to go sun color. Now sun color is a gradient, and we can do the exact same evaluate function on that. So sun color dot evaluate time to get the specific color for that specific time of day. Same for moon, we'll go moon dot color equals moon color dot evaluate time, like so. Okay, so we got changing of the colors. Now, how about setting it up so that we can actually enable or disable the sun and moon based on the time of day? Because we don't want the sun active when it's midnight, as there are still some sort of lighting artifacts that can still shine through at the bottom of objects. So we want to get rid of that. So to do that, we are going to basically enable/disable the sun. And for this, we need to check to see, okay, if the sun intensity is 0 and the sun is still active in the scene, disable it. Otherwise, if the sun intensity is above 0 and the sun is disabled for some reason, re-enable it. Okay, so here we'll go if sun.intensity equals 0 and sun.gameObject.active in hierarchy. Active in hierarchy is either true or false for if the object is enabled or disabled. So if that's the case, then we want to disable the sun because we no longer want it visible. So sun.gameObject.setActive, setActive false. Otherwise, so else if the sun.intensity is greater than 0 and the sun is not active in the hierarchy, so sun.gameObject.active in hierarchy, then we want to go sun.gameObject.setActive true. Now, when it comes to doing the moon, we pretty much want to do the exact same thing. So I'm just going to go ahead and copy and paste this code right here and set that up for the moon. So I'm just going to replace moon for all of these variables right here. And there we go. So now our moon and our sun are going to be enabled and disabled based on if their intensity is equal to 0 or greater than 0. And we also have set up our colors here. So you know what? Let's save the script, return to Unity, and test it out. So if I press play, we should see now that as the sun and the moon go around, they will enable and disable. So once it becomes night, the moon is going to re-enable, and here it is. And we also have the colors changing. You can see the moon shadow right here. As the moon goes down and it becomes daytime again, it's pretty much working. So we have the day-night cycle set up now, but something doesn't look right. When it turns nighttime, we can still see the ocean clear as blue, and it just doesn't look right, okay? We can still see the environment pretty much brightly lit. So how do we fix that? Well, that is where our lighting intensity multiplier and reflections intensity multiplier come in. Okay, so for these two things here, I'm going to go ahead and set the lighting intensity to something like this, where at midnight it is pretty much 0, and then during the day it rises up to 1, stays at 1 for a bit, and then goes down back to 0 at the end of the day. Okay, so during the day we have the intensity multiplier at 1, and at nighttime it's pretty much 0. Now to get this flat curve right here, you can just right click on a key point and go left or right tangent, so right tangent, and set that to linear to basically be flat. Now we want to do the exact same for the reflections intensity multiplier right here, so they're basically going to act in the same way. Okay, so back inside of our script now, let's implement that. So here we are going to create a little comment that just says lighting and reflections intensity. Okay, and to do this, we need to access the render settings. And to do that, we can go render settings dot ambient intensity, whoops, not ambient light, ambient intensity equals, and again, we are going to evaluate the animation curve. So lighting intensity multiplier dot evaluate time. And the exact same for the reflections intensity. So render settings dot reflection intensity equals reflections intensity multiplier dot evaluate time. And modifying the ambient intensity or the lighting intensity and the reflections intensity is going to greatly change how much we can specifically modify the day-night cycle. So if you remember how it looked like before, it still will look kind of weird at night, but now nighttime should look a lot better. Okay, so as the sun rises, it's over there, it's setting, and now nighttime looks a lot more dark, all right? The ocean, it's a lot darker. The moon in the sky, it's a bit hard to see, and there we go. The sun rises up again, and that is our day-night cycle complete. You can of course go through and modify all of these various different settings. It's set up in a way so that you can tweak it just how you like. You can modify the full day length, so maybe we want to make this a much longer day. So let's just say a day is going to be 2 minutes, so enter in 120 seconds right there. Press play, and the sun is moving a lot slower now. Okay, so you can tweak this as much as you like. we can maybe start the day, let's just say we want to start the day early in the morning, so we'll set that to 0.2, and we're going to start the day when it is still nighttime, just as the sun is about to rise. So that is our day-night cycle for our game complete. Again, you can use this in any project that you wish. Pretty much all you need is the sun and the moon objects here set up correctly, and the day-night cycle script. Just drag and drop it into your project, assign all these properties, and you're good to go. So thank you for watching.